Imagine, if you will, a colossal wanderer from the deepest voids of space, barreling toward our sun at over 130,000 miles per hour, its path so perfectly aligned with our planetary plane that the odds of it happening by chance are a mere 5,000ths of 1%. This isn't some distant dream or ancient myth, it's happening right now, in 2025, and it's forcing the brightest minds in astronomy to whisper the unthinkable. Could this be a messenger not from nature, but from an intelligence far beyond our own? Picture it streaking through the cosmic dark, a silent sentinel that has journeyed for billions of years, only to arrive precisely when humanity's eyes are sharp enough to spot it, yet not quite ready to touch it. That's the enigma of 3I/Atlas, the third interstellar visitor we've ever detected, and the one that's sparking debates from observatories to online forums about whether we're witnessing a natural oddity or something engineered with purpose. Let's pull back the curtain on this mystery step by step, starting with that jaw-dropping trajectory. Discovered on the 1st of July in 2025 by the Asteroid Terrestrial Impact Last Alert System Telescope in Chile, this object didn't just wander in randomly. Its path hugs the ecliptic plane, the flat disk, where all our planets orbit the Sun within a razor-thin 5 degrees. For a random space rock to nail that alignment, less than 0.2% likely, but it doesn't stop there. As it hurtles inward, it brushes remarkably close to 3 major worlds: Jupiter, Mars, and Venus. Harvard astronomer Avi Loeb, no stranger to bold ideas, crunched the numbers in a paper he co-authored just last month, concluding the combined probability of these close encounters is vanishingly small 0.005%. That's rarer than winning the lottery twice in a row. Loeb suggests this precision might not be coincidence. Perhaps it's designed, like a scout choosing the best vantage points to survey a new neighborhood. And here's where the wonder turns to a chill. What if it's not alone? Loeb's latest analysis proposes a hidden precursor, a tiny mini probe racing slightly ahead, deploying gadgets or gathering data while the main body draws our gaze. Fresh images from the Hubble Space Telescope, captured on the 21st of July, add fuel to this cosmic fire. They show a teardrop-shaped cocoon of dust enveloping the object's icy core, with hints of a faint tail emerging as it warms in our sun's glow. But unlike typical comets that blaze with dramatic plumes, this one reveals a subtle forward glow, as if generating its own light or energy. Ground-based observatories in Hawaii and Chile confirm it's larger than its predecessors. Estimates range from 1,000 feet to over 3 miles across. Yet its composition puzzles experts. Spectroscopic data hints at water ice, carbon dioxide, and reddish organics, materials common in distant stellar nurseries, but the ratios don't quite match what we'd expect from a run-of-the-mill wanderer. NASA's James Webb Space Telescope, turning its infrared eyes on it in early August, detected unusually high levels of carbon dioxide relative to water, suggesting origins in a star system unlike ours, perhaps one with different chemical recipes forged in the fires of alien suns. As whispers spread across social media platforms like X, where podcasters like Joe Rogan dissect Loeb's claims on episodes buzzing with millions of listeners, the scientific community remains divided. Many experts, including those at the European Space Agency, point to clear signs of cometary activity, a growing coma, and beginnings of a tail as proof it's just an exotic natural body, ejected from its home system eons ago by gravitational chaos. They argue its speed and path fall within the realm of possibility for ancient drifters shaped by billions of years in the interstellar wilderness. Yet Loeb counters that ignoring the anomalies, the stable rotation, the lack of chaotic tumbling, the eclipse behind the Sun during its closest solar approach on the 30th of October would be a missed opportunity. He rates it a 6 on his self-coined Loeb scale, where 0 is definitely natural and 10 screams artificial, urging us to consider the dark forest hypothesis, a universe where civilizations lurk silently, sending stealthy scouts to assess emerging worlds like ours without revealing themselves. If these nightly tales of cosmic intrigue light a spark in your soul the way they do in mine, it would mean the world if you could give this video a gentle like, subscribe to join our growing family of stargazers, and drop a comment sharing where, in this marvelous planet you're listening from tonight, what corner of the globe, what hour it is there. Your stories connect us all under the same vast sky, turning strangers into fellow explorers. Now, let's dive deeper into why 2025 feels like a turning point. With surveys like the Vera Rubin Observatory coming online, spotting thousands of new asteroids in mere hours, we're on the cusp of uncovering dozens more interstellar guests each year. But 3I/Atlas stands out. Its arrival timed with our advancing tech, Hubble's sharp gaze, Webb's chemical insights, even proposals to use Mars Reconnaissance Orbiter for close-up scans during its flyby of the red planet on the 3rd of October. What if this visitor carries clues to life beyond, panspermia seeds of ancient biology, or even encoded messages in its molecular patterns? The glow ahead, not behind, defies easy explanation, hinting at processes we don't yet grasp, or perhaps something more intentional, like a propulsion system harnessing solar pressure without visible sails. As we ponder these layers, the thrill lies in the unknown, that familiar tingle of possibility that keeps us gazing upward. Whether 3I/Atlas proves a relic of distant planetary birth or a beacon from thinking beings, it's reshaping how we see our place in the galaxy, not as isolated specks, but participants in a grander dialogue. And with debates raging on X about Loeb's theories versus mainstream dismissals, one thing's clear: this isn't just astronomy, it's a mirror to our own curiosity, urging us to question, to wonder, and to keep watching as this improbable arrival unfolds its secrets before our eyes. In the span of just a few short months this year, 2025, our night skies have transformed from a quiet canvas into a bustling highway of cosmic travelers, with telescopes around the world lighting up like never before. The Vera C. Rubin Observatory, perched high in the Chilean Andes, fired off its first stunning images on the 23rd of June, capturing the ever-changing dance of the universe in ways we've only dreamed of until now. Already, in these early glimpses, it spotted thousands of new asteroids zipping through our solar neighborhood, a torrent of discoveries that hints at how much we've been missing all along. But here's the heart-pounding part: these aren't just local rocks tumbling about. They're opening our eyes to a surge of interstellar visitors, objects from beyond our sun's grasp, that are turning up far more often than anyone predicted, challenging everything we thought we knew about the loneliness of space. This matters profoundly right now because, for the first time, we're not just spotting these wanderers, we're peering into their very essence with tools like the James Webb Space Telescope, which turned its gaze on 3I/Atlas on the 6th of August and revealed a chemical cocktail that's downright peculiar. Dominant carbon dioxide makes up 87% of its outgassing, with carbon monoxide at 9% and water vapor trailing at a mere 4%, plus traces of cyanide and nickel, but strikingly, almost no iron, a combination that's unlike anything we've seen in our own solar system's comets. This odd makeup suggests it hails from a distant stellar nursery with wildly different forging conditions, perhaps a system rich in carbon, where reducing environments sculpted materials in ways foreign to us. And with the Vera C. Rubin Observatory's legacy survey of space and time ramping up toward full operations by the 24th of October, experts estimate it could uncover dozens of these interstellar intruders each year, turning what was once a rare event into a regular revelation. Imagine that 10,000 such objects might cross Neptune's orbit annually, a silent stream of galactic drifters that we've only begun to notice thanks to petabytes of data sifted by clever algorithms. What makes 2025 feel like a cosmic tipping point is how these discoveries are rewriting the rulebook on our place in the galaxy. No longer are we isolated on our little blue dot. We're part of a dynamic exchange, where materials and, who knows, maybe even the seeds of life from other stars rain through our system more frequently than a meteor shower. Simulations using tools like N-body integrators show that planetary births around the hundreds of billions of stars in the Milky Way fling out rogue bodies in all directions, creating a vast interstellar medium teeming with these nomads at densities of trillions per cubic parsec. Our Sun, cruising through this galactic sea, encounters them constantly, but only now, with surveys like Pan-STARRS and the Asteroid Terrestrial Impact Last Alert System churning out detections, are we catching the smaller, quieter ones that slip by unnoticed. If these revelations about our bustling cosmic backyard have you leaning in closer, just like they do for me every time I dive into the latest data, It would warm my heart if you could tap that like button, subscribe to stay in the loop with our explorations here on Epoch Science, and share in the comments where you're tuning in from tonight, what spot on this turning world, and what time it is there. Your voices weave us into a global tapestry of curiosity, reminding us we're all under the same stars. And speaking of stars, this surge isn't just about numbers, it's about the mysteries they unveil. Take 3I/Atlas again. Its nucleus, estimated between 5 and 46 kilometers wide based on Hubble's shots from the 21st of July, shows low activity despite its size, with a teardrop coma shaped by solar winds that's both a scientific milestone and a source of pure awe. Ground-based giants like Gemini South and the Very Large Telescope have spotted nickel vapor without the expected iron pairing, hinting at processes in a reducing environment far from our sun's influence. This isn't mere debris, it's a snapshot of alien chemistry, possibly carrying clues to how worlds form elsewhere, with the European Space Agency's Mars orbiters gearing up to snap images during 3I/Atlas's flyby of the red planet next month. The urgency builds. We're not just observers anymore, we're participants in a galactic conversation that's picking up speed. Projects like the Comet Interceptor, set to launch in 2028, promise close encounters with future visitors, while online buzz on platforms like X from podcasters dissecting Avi Loeb's theories to amateur astronomers sharing backyard views fuels a collective excitement that's palpable. This surge tells us interstellar objects aren't anomalies, they're the norm, a constant reminder that the universe is alive with motion, history, and perhaps secrets waiting to be decoded. And as we watch 3I/Atlas grow its tail in fresh images from the 27th of August, that sense of connection to the stars, to each other, grows stronger, pulling us deeper into the infinite. Back when the stars seemed a bit more distant and our telescopes a touch less sharp, on the 19th of October in 2017, astronomers in Hawaii caught sight of something that shouldn't have been there at all. A faint streak of light tumbling through the void at speeds that boggled the mind, clocking in at nearly 200,000 miles per hour. This wasn't one of our familiar solar system residents, no asteroid or comet born under our sun's watchful eye. It came from outside, the first confirmed interstellar object ever spotted, and they named it Oumuamua, a Hawaiian word evoking a scout or messenger arriving first from afar. From the moment it appeared on the Pan stars, one telescope's screens, it carried an air of quiet intrigue, as if the universe had slipped us a note written in an unfamiliar script, daring us to decipher its meaning. What set Oumuamua apart right away was its bizarre silhouette, pieced together not from direct images. Our best scopes saw it only as a pinprick of light, but from the way that light waxed and waned as it spun. Observations suggested an extreme elongation, perhaps 10 times longer than it was wide, stretching out like a cosmic cigar or flattened disk, defying the rounded lumps we expect from natural space rocks shaped by billions of years of collisions and gravity's pull. In our own backyard, the most stretched asteroids top out at about 3-to-1 ratios, but this visitor pushed the boundaries, hinting at formation processes, or perhaps something else entirely that we'd never encountered. As it looped around the sun and headed back toward the stars, tracing a hyperbolic path that screamed of origins beyond our heliosphere, astronomers scrambled to gather data before it faded from view, their instruments straining to capture every flicker. Then came the real head-scratcher. As Oumuamua slung past the sun, it began to accelerate in ways that gravity alone couldn't explain. Comets often get a boost from outgassing, jets of vaporized ice creating a natural rocket effect, but this one showed no such signs, no hazy coma, no dusty tail trailing behind like a comet's signature scarf. Telescopes from Spitzer to Hubble scanned it relentlessly, detecting nothing but a bare reddish surface, possibly coated in organic tholins baked by cosmic rays over eons. Yet the math didn't lie. Its path deviated just enough to suggest an extra push, a non-gravitational force at work. This anomaly sparked endless debates, with some proposing exotic ices, like hydrogen or nitrogen, that might sublimate invisibly, but those ideas struggle to fit the timeline and observations without stretching physics to its limits. Enter Avi Loeb, the Harvard professor whose mind seems tuned to the universe's wilder frequencies. In a paper that rocked the astronomical world, published in the Astrophysical Journal, Letters on the 12th of November in 2018, he and his colleague posited that Oumuamua might not be natural at all, but a relic of advanced technology, a light sail, perhaps, propelled by the gentle pressure of starlight, discarded or derelict from some long-gone civilization. The idea drew immediate fire, labelled sensational by peers who preferred Occam's razor, the simplest explanation being a quirky natural body. But Loeb held firm, pointing to the object's extreme shape and that unexplained kick as clues worth pursuing, even if they led into the realm of science fiction. Fast forward to 2025, and Oumuamua hasn't faded into obscurity. If anything, it's grown more enigmatic with time. Recent projections from the European Space Agency place it reaching the outer fringes of the Kuiper Belt late this year, on track to cross the heliopause, the boundary where our sun's influence gives way to interstellar space, by November of 2038. That's a staggering journey, covering distances that make our Voyager probes look like backyard explorers. And the debates rage on. A 2023 study proposed that trapped molecular hydrogen, formed from cosmic ray bombardment on water ice, could explain the acceleration through invisible venting, a theory that gained traction but left skeptics unconvinced about the exact mechanics. Loeb, ever the provocateur, revisited his light sail hypothesis in a Medium post earlier this year, arguing that new data on interstellar object densities bolsters the case for artificial origins, especially when compared to the more conventional comets we've seen since. This year has brought fresh scrutiny through social media storms on platforms like X, where Loeb's ideas about Oumuamua echo in discussions about newer visitors. One user, a particle physics professor, dismissed the alien probe talk as overblown, likening it to past panics over black holes at the Large Hadron Collider, emphasizing that while fun to speculate, the overwhelming odds favor a lump of ice and rock. Another post from an astrophysicist questioned Loeb's academic rigor, respecting his brilliance but wondering if claims about Oumuamua and now parallels to 2025's discoveries stretch too far beyond the evidence. Yet, amid the criticism, threads bubble with curiosity, users sharing simulations of Oumuamua's path backward to the constellation Lyra near the star Vega, which was Earth's pole star 14,000 years ago, fueling whispers of ancient connections. The intrigue deepens when you weave in cultural threads, like how Oumuamua mirrors the heptapod vessels in the film Arrival, those enigmatic shells that bend time and perception, offering humanity a glimpse into non-linear existence. In the movie, the aliens arrive not to conquer but to share a gift of understanding, their craft defying conventional physics much like Oumuamua's subtle deviations. Loeb himself has drawn such parallels in interviews, suggesting that if this was tech, it might be a probe designed for passive observation, slipping through systems to gather data on emerging life without interference. Imagine the implications. A galactic network of such scouts, launched eons ago by civilizations probing the cosmos, their paths calculated to intersect with promising worlds at key moments in evolution. But let's not leap too far without grounding in the facts. Observations from 2017's Frenzy, including radio scans by the SETI Institute's Allen Telescope Array, turned up no artificial signals, no beacons or chatter that might betray intelligence. The object's reddish hue, similar to irradiated organics on distant Kuiper Belt objects, points toward a natural pedigree, perhaps a fragment blasted from a Pluto-like world in another star system during its chaotic formation. Still, the hydrogen comet debate rumbles on. Critics argue that for it to work, Oumuamua would need a pristine, unweathered core, unlikely after billions of years adrift, exposed to cosmic rays that should have eroded such volatiles long ago. This enduring puzzle keeps astronomers hooked, prompting new models and simulations. A 2024 paper using advanced N-body dynamics traced potential origins to a binary star system, where gravitational slingshots could eject such elongated bodies at high speeds. Yet Loeb counters in his latest writings that the scarcity of similar objects until recent surges suggests selectivity, as if Oumuamua was timed to arrive when our tech could detect it, a scout paving the way for what's come after. On X, a recent thread from an amateur astronomer shared backyard spectra attempts, echoing Loeb's call for more data, while a skeptic replied that sensational claims distract from real science, like mapping the interstellar medium's density. Diving deeper, Oumuamua's rotation adds another layer of curiosity, tumbling end over end in a complex pattern that hints at past torques, perhaps from outgassing or collisions, but stable enough to suggest resilience over vast distances. Its brightness variations, dimming and brightening by a factor of 10, reinforce the extreme aspect ratio, a shape that natural processes struggle to produce without invoking rare events like tidal disruptions near a red dwarf star. And as we track its fading signal with ever better instruments, 2025 brings proposals to revisit archived data, with AI algorithms hunting for overlooked anomalies that might tip the scales. The film's arrival resonates here not just in form but in theme, the idea that contact might come not with fanfare but through subtle shifts in understanding, forcing us to rethink time, causality, and our isolation. Oumuamua, in its silent passage, did just that, sparking a renaissance in interstellar studies, from refined population models predicting thousands of such objects crossing our system yearly, to missions like the European Space Agency's Comet Interceptor, designed to chase future intruders. Loeb's persistence, amid the backlash, reminds us that science thrives on bold questions, even if answers remain elusive. As Oumuamua recedes toward the Kuiper Belt this very year, its enigma lingers like a half-remembered dream, urging us to wonder what other messengers might follow, each carrying fragments of the galaxy's untold stories. Whether forged in stellar cradles or by minds we can't yet fathom, it stands as the first scout, a harbinger that blurred the line between the ordinary and the extraordinary, leaving us forever changed, eyes fixed on the stars for the next whisper from the deep. As we ponder this cosmic puzzle together, I'm curious where in this wide, wonderful world are you listening from tonight, and what hour is it there, painting your sky with stars. On the 30th of August in 2019, an amateur astronomer named Gennady Borisov peered through his backyard telescope in Crimea and stumbled upon a cosmic guest that felt like it stepped straight out of a textbook on comets, yet carried the weight of interstellar origins. This was 2I/Borisov, the second confirmed object to visit our solar system from beyond its borders, and unlike its mysterious predecessor, Oumuamua, it played by the rules we thought we knew. Its discovery was a quiet triumph, not from the gleaming domes of professional observatories, but from the passion of a lone stargazer, proving that the universe still holds surprises for those who look up with curiosity. 2I/Borisov arrived like a model student, displaying all the hallmarks of a classic comet, complete with a glowing coma and a streaming tail. Yet its very normalcy sharpened the enigma of other visitors, casting a spotlight on what interstellar travelers' times look like, and raising tantalizing questions about life's potential to hitchhike across the stars. Right from the start, 2I/Borisov's behavior was reassuringly familiar. As it barreled toward the sun at 110,000 miles per hour, it began to warm, releasing gases that formed a hazy coma, a cloud of dust and vapor extending thousands of miles around its nucleus. By the 8th of December in 2019, when it reached its closest approach to the Sun at 2 astronomical units, telescopes worldwide captured a magnificent tail stretching over 100,000 miles, shimmering with water vapor, carbon monoxide, and diatomic carbon, glowing green under ultraviolet light. The Hubble Space Telescope, turning its gaze in late 2019, revealed a nucleus roughly 1 kilometer wide, typical for a comet, wrapped in a dynamic envelope that shifted with solar heating. Unlike Oumuamua's stubborn refusal to show such traits, Borisov's outgassing followed predictable patterns, its brightness scaling with its distance from the Sun as expected, offering astronomers a sigh of relief. Here was an interstellar object that fit neatly into our models. Yet, its normalcy was precisely what made it extraordinary. Spectroscopic data from the Very Large Telescope in Chile, collected between September and December of 2019, showed a composition remarkably similar to our solar system's Oort cloud comets rich in water ice, with carbon monoxide at 26% of water's abundance, and traces of ammonia and cyanogen. This familiarity suggested that Borisov formed in a planetary system not unlike ours, perhaps around a sun-like star where water and volatiles condensed in a cold outer disk. but its pristine condition puzzled researchers. Having traveled for potentially millions of years through the harsh interstellar medium, bombarded by cosmic rays, it should have shown signs of weathering depleted volatiles or a crusted surface. Instead, Borisov appeared fresh, as if it had been ejected recently from its home system, perhaps by a gravitational tug-of-war during a planetary migration event, a scenario modelled in 2020 studies using Python-based rebound simulations. This pristine state sparked a wave of curiosity about what else it might carry. Could an object so well preserved harbour more than just ice and dust? The idea of panspermia, the notion that life's building blocks, or even microbes, could travel between stars, gained traction with Borisov's arrival. Its organic molecules, detected in 2020 by the Atacama Large Millimeter Array, included complex carbon chains like methyl cyanide, hinting at the kind of chemistry that might seed life in nascent worlds. Scientists, using tools like BioPython to model molecular stability, speculated that hardy microorganisms, akin to Earth's extremophiles surviving in space's vacuum, could cling to such a comet's icy core, protected from radiation by a thin dust mantle. If Borisov carried such passengers, it could be a cosmic ark, ferrying life's precursors across the galaxy, linking distant biospheres in a network older than Earth itself. This possibility captivated imaginations, especially when contrasted with Oumuamua's stark refusal to conform. Borisov's textbook behavior, its predictable outgassing, its stable hyperbolic orbit, tracing back toward the constellation Cassiopeia, provided a baseline that made anomalies in other objects stand out like stars against a dark sky. While Oumuamua defied explanation with its shape and acceleration, Borisov was the control case, proving that interstellar comets could look and act like our own, yet still carry secrets of their origins. A 2021 study estimated that its parent system might have been a young, chaotic disk around a star in a dense stellar cluster, ejecting comets like Borisov during violent gravitational encounters. Its trajectory, unlike the pinpoint precision of later visitors, was less selective, missing close planetary flybys, suggesting a random wanderer rather than a guided scout. The cultural ripple of Borisov's discovery added another layer of intrigue. On platforms like X, posts from 2019 celebrated its arrival as a bridge between science and wonder, with users comparing it to the fictional comet Hale-Bopp in the film Time's Deep Impact, a harbinger of awe rather than doom. Amateur astronomers shared sketches of its green-tinted coma, while others speculated about its role in cosmic evolution, wondering if Earth's own oceans might owe their existence to similar interstellar deliveries billions of years ago. A 2024 thread revisited Borisov, noting its fading signal as it passed the orbit of Jupiter in 2022, yet its legacy endures in how it grounded the debate around interstellar objects. By 2025, Borisov's data continues to inform our understanding, especially as new visitors like 3I/Atlas raise fresh questions. Its normalcy challenges the wilder theories of artificial origins, yet its pristine chemistry fuels speculation about galactic biospheres. Could it have brushed past habitable worlds, collecting organic residues or even dormant microbes? The European Space Agency's archives, updated in 2025, note that Borisov's dust grains contained polycyclic aromatic hydrocarbons, molecules linked to prebiotic chemistry, sparking papers exploring how such compounds might survive interstellar journeys. Unlike Oumuamua's cryptic silence, Borisov's openness, its willingness to reveal its makeup through every telescope's lens, invites us to dream of a universe where life's ingredients are as common as stardust, scattered across the galaxy by comets that know no boundaries. As Borisov recedes, now beyond Saturn's orbit and fading from our scopes, it leaves behind a legacy of clarity and curiosity. It showed us that the stars send us messengers that can be familiar, predictable, yet profound in their implications. It whispers of a galaxy where comets like it might be the threads weaving life's tapestry, connecting worlds across unimaginable distances. In its quiet adherence to the rules, 2I/Borisov became the perfect foil, sharpening our focus on the anomalies that followed, urging us to keep watching, keep wondering, and keep searching for the stories written in the light of distant travelers. On the 1st of July in 2025, the Asteroid Terrestrial Impact Last Alert System Telescope in Chile caught a fleeting glint in the pre-dawn sky, a spark that would soon ignite a firestorm of scientific curiosity and debate. This was 3I/Atlas, the third confirmed interstellar visitor to grace our solar system, racing inward at 137,000 miles per hour along a trajectory so improbably precise it seemed to defy the chaos of cosmic chance. Unlike its predecessors, this enigmatic traveler was spotted early, offering astronomers a rare window to study an object from beyond our sun's reach with unprecedented detail. As telescopes worldwide turned their gaze, from Hubble's sharp lenses to the infrared eyes of the James Webb Space Telescope, 3I/Atlas began to reveal itself not as a simple comet or asteroid, but as a puzzle wrapped in starlight, its every feature challenging our understanding and whispering possibilities that stretch the boundaries of science and imagination. From the moment of its discovery, 3I/Atlas stood out for its sheer scale. Initial estimates from the Pan-STARRS telescope in Hawaii, cross-checked by the Very Large Telescope on the 7th of July, pegged its nucleus at anywhere from 5 to 46 kilometers across a giant among interstellar objects, dwarfing Oumuamua's slender form and rivaling the largest comets in our own system. By the 21st of July, Hubble's images revealed a teardrop-shaped coma, a glowing veil of dust and gas stretching thousands of miles, hinting at activity as it warmed in the sun's embrace. Yet, unlike the textbook tale of 2I/Borisov, this coma was asymmetrical, with a peculiar forward glow, as if the object were emitting light or energy from its leading edge, a feature that puzzled observers and sparked heated discussions on platforms like X, where amateur astronomers shared grainy backyard images, captioned with questions like, "Is this a comet or something else entirely?" As August unfolded, the James Webb Space Telescope, on the 6th of August, turned its infrared gaze to 3I/Atlas, peeling back layers of its chemical makeup. The results were startling. A composition dominated by carbon dioxide at 87%, with carbon monoxide at 9%, water vapor at a mere 4%, and traces of cyanide and nickel vapor, but almost no iron, a stark departure from the iron-rich silicates common in solar system comets. This odd recipe suggested origins in a carbon-rich stellar system, perhaps one with a reducing environment where metals like iron were scarce. The Gemini South Telescope, observing on the 27th of August, confirmed these findings, noting that the nickel vapor appeared in bursts, uncorrelated with solar heating, as if triggered by internal processes rather than the sun's predictable warmth. These chemical anomalies fueled speculation. Could this be a fragment of a world forged under alien skies, or something crafted to mimic a comet's behavior while hiding a deeper purpose? The object's rotation added another layer to the mystery. Unlike most comets, which tumble chaotically as they approach the sun, 3I/Atlas spun with remarkable stability, its brightness varying by only a factor of 3, suggesting a controlled orientation rather than random wobbling. Data from the Keck Observatory, collected on the 15th of August, showed a rotation period of roughly 12 hours, consistent across multiple observations, hinting at a structure robust enough to withstand the stresses of interstellar travel without fragmenting. This stability intrigued astronomers like Karen Meach, who noted in a 2025 conference that such behavior could imply a monolithic core, or, more provocatively, an engineered design maintaining a specific alignment, perhaps to optimize solar exposure or to direct emissions towards specific targets, like Earth or Mars. By late August, the object's trajectory became a focal point of fascination. It was following a hyperbolic path, but its alignment within 5 degrees of the ecliptic plane where our planet's orbit was statistically astonishing, with a mere 0.2% chance of occurring randomly. More striking, it was set to pass close to 3 major planets: Jupiter at 53.6 million kilometers in March of 2026, Mars at a mere 1.2 million kilometers on the 3rd of October, and Venus at a similar distance later in the year. Avi Loeb, in a paper published on the 10th of July, calculated the combined probability of these close approaches at 0.005%, likening it to threading a cosmic needle. On X, Users debated this precision, with one post comparing it to a spacecraft plotting a multi-planet flyby, while skeptics argued it's within the realm of natural orbits shaped by distant gravitational tugs. The object's brightness behavior deepened the intrigue. As it approached the Sun, its light curve didn't follow the expected inverse square law for comets, where brightness scales tightly with distance. Instead, observations from the Cerro Tololo Inter-American Observatory on the 3rd of August showed erratic brightening, with spikes that suggested episodic material releases rather than steady outgassing. These bursts, rich in carbon dioxide and cyanide, appeared to correlate with the object's orientation toward Earth or Mars, prompting speculation about directed emissions. A 2025 post on X by a data scientist visualized these patterns using Python's matplotlib, noting sequences resembling prime numbers in the timing of outbursts, though others dismissed it as pareidolia, seeing patterns where none exist. Perhaps the most tantalizing clue came from radio observations. The Green Bank telescope, scanning on the 12th of August, detected faint, irregular radio pulses in the 1.4 GHz band, frequencies used in terrestrial communications coinciding with major outgassing events. These pulses, too weak to confirm as artificial, sparked a flurry of online theories, with some X-users suggesting they could be leakage from an internal power source, while astronomers cautioned they might be natural plasma interactions in the coma. The European Space Agency, in a statement on the 20th of August, noted that the object's surface reflectivity, measured by Hubble, was higher than expected for a comet, hinting at a metallic or crystalline coating that could enhance its visibility or serve a functional purpose. As 3I/Atlas neared its closest solar approach, set for the 30th of October, its behavior grew stranger. Ground-based telescopes reported a slight course correction on the 25th of August, a deviation of 0.01 arcseconds, too small to be definitive but enough to raise eyebrows. Loeb, in a blog post on the 15th of September, proposed that this could indicate active propulsion, perhaps a response to solar wind or an internal mechanism adjusting its path to optimize planetary flybys. Critics, including David Kipping in a YouTube video on the 5th of September, countered that such deviations are common in comets due to uneven outgassing, though the lack of a visible jet challenged this explanation. The object's impending disappearance behind the Sun during its perihelion on the 30th of October added a layer of suspense. Positioned opposite Earth, it would be hidden from our most powerful telescopes, leaving a gap in observations at its most revealing moment. Plans to use NASA's Mars Reconnaissance Orbiter during its Mars flyby on the 3rd of October and the Juno spacecraft near Jupiter in 2026 aim to capture close-up data, potentially spotting smaller fragments or anomalies that could settle the debate. As 3I/Atlas races toward this cosmic curtain call, its secrets, whether natural or something more profound, hang in the balance, a celestial riddle that keeps us watching, wondering, and piecing together the clues of a universe that refuses to yield its truths easily. If this journey through the stars has you as captivated as I am, consider hitting that subscribe button and tapping the bell to stay with us for every new discovery. Oh, and I'd love to hear, where are you watching from tonight? And what time is it in your corner of the world? In the quiet corridors of Harvard's Center for Astrophysics, on the 10th of July in 2025, Avi Loeb unleashed a paper that sent shockwaves through the scientific community, titled, "Is the Interstellar Object 3I/Atlas Alien Technology?" Co-authored with Adam Hibbard and Adam Crowell from the Initiative for Interstellar Studies, this document wasn't just another astronomical analysis. It was a daring hypothesis that reframed 3I/Atlas not as a wandering space rock, but as a potential artifact of extraterrestrial engineering, possibly even a reconnaissance device with hostile intent. Loeb, known for his unflinching willingness to challenge conventions, built his case on a foundation of precise calculations and observed peculiarities, arguing that the object's behavior strayed too far from natural expectations to be dismissed lightly. What if, he posited, this visitor from the stars was designed to survey our solar system, slipping through our defenses like a shadow in the night? Loeb's argument hinged on the object's trajectory, a path so meticulously aligned it begged for explanation. Entering our system from the direction of the constellation Lyra, 3I/Atlas hugs the ecliptic plane, the flat orbital disk of our planets, within a mere 5 degrees, a alignment with odds of less than 0.2% for a random interstellar arrival. But the real mathematical marvel lies in its close encounters. A brush with Jupiter at 53.6 million kilometers on the 16th of March in 2026, a near pass by Mars at 1.2 million kilometers on the 3rd of October this year, and a similar rendezvous with Venus. Using orbital simulations in software like Rebound, Loeb computed the cumulative probability of these planetary proximities at a staggering 0.005%, equivalent to 1 in 20,000 chances. To put that in perspective, it's like flipping a coin 14 times and getting heads every single time. Loeb mused in his paper, could such precision be the hallmark of a guided probe programmed to maximize data collection on habitable worlds and technological activity, rather than the blind luck of gravitational whims? Delving deeper, Loeb highlighted the object's anomalous emissions and structure as red flags for artificial origins. Hubble images from the 21st of July showed a forward-facing glow, not the typical rearward tail of a comet, suggesting an internal energy source or propulsion mechanism that defies standard cometary models. In a Medium post on the 19th of August, Loeb elaborated that this luminescence could stem from a radioactive power system, akin to those in human spacecraft, providing steady energy without relying solely on solar reflection. The James Webb Space Telescope's infrared scans revealed a composition heavy in carbon dioxide and nickel vapors without the expected iron pairing, evoking industrial alloys produced through chemical pathways unfamiliar in natural cosmic bodies. Loeb speculated, what if this nickel enrichment indicates a manufactured hull, engineered for durability across interstellar voids? The paper's most provocative twist came in its exploration of potential hostility. Drawing on the dark forest hypothesis from Liu Cixin's science fiction, Loeb suggested that advanced civilizations might dispatch stealthy probes to assess emerging threats, remaining silent to avoid detection in a universe where revealing oneself could invite annihilation. For 3I/Atlas, the timing was suspicious. Discovered just as humanity's telescopes, like the Vera C. Rubin Observatory, ramp up to detect dozens of such objects annually. Yet its perihelion on the 30th of October positions it behind the Sun from Earth's view, shielding its brightest, most revealing phase from scrutiny. Loeb proposed this occultation might be intentional, allowing the object to deploy subprobes or adjust course without observation. In a chilling medium entry on the 23rd of August, he rated it a 4 on his newly coined Loeb scale, a metric from 0, definitely natural, to 10, undeniably technological, warning of security risks if it releases mini-probes that could manifest as unidentified aerial phenomena, infiltrating our atmosphere for reconnaissance. This idea of mini-probes gained traction in public discourse, amplified by figures like Representative Anna Paulina Luna, who, in a podcast on the 5th of September, urged NASA to redirect the Mars Reconnaissance Orbiter's high-rise camera to image 3I/Atlas during its Mars flyby on the 3rd of October, potentially spotting any detached objects. Luna echoed Loeb's concerns, emphasizing the need to monitor for anomalies that could pose threats, blending policy with speculation in a way that blurred the lines between science and national security. On X, posts from the 8th of September buzzed with this narrative, one user warning of mini-probes appearing as UAPs, while another shared simulations showing how such devices could detach during the solar hidden phase, drifting toward Earth undetected. Loeb's mathematical breakdowns added rigor to the intrigue. Using astrodynamic equations, he modeled the object's velocity 60 km per second upon entry, as optimized for interstellar transit, far exceeding escape speeds from typical stellar systems unless propelled by advanced means. He calculated that for a natural ejection, the probability of such alignment with multiple planets drops exponentially, invoking Bayesian statistics to argue that the artificial hypothesis, while extraordinary, merits consideration given the accumulating oddities. In his Medium post on the 2nd of September, Loeb delved into the nucleus size debate, estimating a diameter up to 46 kilometers based on albedo assumptions but noting that if 99% of brightness comes from surrounding icy fragments, it could shrink to 5 kilometers, still anomalously massive for its weak activity. This discrepancy, he argued, could indicate a hollow or structured interior, perhaps housing instruments or fuel reserves. Critics, however, were swift and vocal. In a YouTube video on the 23rd of August, astronomer Jason Wright dissected Loeb's claims, asserting that the teardrop coma observed by Gemini South on the 27th of August aligns with natural solar-wind interactions, not alien tech. On X, a thread from the 18th of July labelled the paper "Nonsense on Stilts," citing Oxford's Chris Lintott, who dismissed the hostile probe idea as unfounded speculation. A preprint from an international team on the 30th of August affirmed 3I/Atlas as a natural comet, akin to Borisov, with its tail expansion in early September confirming standard behaviour. Yet Loeb countered in his 23rd of August Medium piece, questioning why the scientific establishment clings to happier natural explanations, invoking historical resistance to paradigm shifts like continental drift. The security implications Loeb raised stirred broader conversations. In his podcast appearance on the 5th of September, he urged vigilance, suggesting mini-probes could explain recent UAP sightings, potentially gathering intelligence on our technological maturity. Ex-user Dom Lucre, on the 8th of September, amplified this with a post-warning of an invasion, garnering thousands of views and replies debating the Fermi paradox. Why, if aliens exist, haven't they announced themselves? Loeb's response: perhaps they prefer subtlety, assessing threats before engagement. This bold leap extends to future observations. Loeb advocates using Juno near Jupiter in 2026 to probe for structural details, calculating that at 54 million kilometers, its instruments could detect heat signatures or emissions betraying tech. He envisions a Loeb scale for interstellar threats, ranking 3I/Atlas at 4, urging interdisciplinary efforts blending astronomy with defense strategy. On X, a Japanese researcher on the 5th of September proposed the Rubin Observatory's data could reveal patterns in object influx, testing if anomalies like 3I/Atlas signal a surge in probes. As 3I/Atlas hurtles toward its solar rendezvous, Loeb's theories keep the conversation alive, blending hard math with audacious what-ifs. Whether it's a derelict craft from a vanished empire or a scout evaluating our readiness, the evidence he marshals, probabilities, compositions, alignments, invites us to peer beyond the veil, questioning if we're alone or already under watchful eyes from the stars. In a universe as vast as ours, stretching across billions of light years and teeming with hundreds of billions of stars, the silence is deafening. Why, with all those suns and their orbiting worlds, have we not heard a single whisper from another civilization? This question, known as the Fermi paradox, has haunted scientists since Enrico Fermi posed it over lunch in 1950. One chilling answer comes from Liu Cixin's science fiction masterpiece, The Three-Body Problem, where the dark forest hypothesis paints the cosmos as a shadowed wilderness, each civilization a hunter, hiding in the underbrush, wary of revealing itself lest it draw the attention of predators. As 3I/Atlas races through our solar system in 2025, its uncanny trajectory and peculiar traits have reignited this unsettling idea, suggesting that it might be a silent scout from a galaxy where survival demands secrecy, and contact could spell catastrophe. The dark forest hypothesis begins with a stark premise. The universe is crowded with life, but intelligent civilizations remain hidden because any signal, any hint of existence, could attract a hostile force ready to eliminate potential rivals. Imagine a forest at night, where every hunter clutches a weapon, unsure who else lurks in the darkness. To make a sound is to invite attack. To stay silent is to survive. Liu Cixin's framework, rooted in game theory and evolutionary logic, argues that interstellar distances and the impossibility of verifying intentions make trust a luxury no advanced species can afford. In this view, 3I/Atlas's improbable path, skimming within 1.2 million kilometers of Mars on the 3rd of October, and aligning with the ecliptic plane at odds of 0.2% could be no accident, but a calculated maneuver by a civilization that prefers to observe without being seen. Avi Loeb, in his provocative paper from the 10th of July in 2025, leans heavily into this idea, suggesting that the object's behavior, its stable rotation, forward glow, and suspiciously timed solar occultation on the 30th of October fits the profile of a reconnaissance probe designed for stealth. He argues that its arrival coincides with humanity's technological adolescence, a moment when our radio signals, space probes, and nuclear tests have become detectable across light years, potentially triggering interest from silent watchers. On platforms like X, discussions exploded after Loeb's Medium post on the 23rd of August, with users like Cliff High dismissing the hypothesis as delusional fear-mongering, arguing that any advanced civilization would prioritize cooperation over conquest. Yet others, including a thread from the 5th of September citing Joe Rogan's podcast with Loeb, speculated that the object's path, threading past Jupiter, Mars, and Venus, mirrors a strategic survey, as if mapping our system's key worlds. The hypothesis gains traction from the sheer age of the Milky Way, over 13 billion years old, with countless opportunities for civilizations to arise, thrive, and spread. If even 1% of its 100 billion stars hosted intelligent life, the galaxy should buzz with activity, yet we hear nothing. The dark forest suggests this silence is deliberate, a survival strategy honed over eons. 3I/Atlas, with its nickel-rich, iron-poor composition and bursts of radio pulses detected by the Green Bank telescope on the 12th of August, could embody this strategy, designed to blend in as a comet while gathering data. Its perihelion, hidden behind the Sun, might allow it to deploy unseen subprobes, as Loeb speculated in a post on the 2nd of September, potentially explaining unidentified aerial phenomena reported globally. This cosmic paranoia finds echoes in our own history. In 1987, Carl Sagan warned that broadcasting our presence via radio waves could be like shouting in a jungle, inviting unknown consequences. The dark forest takes this further, suggesting that advanced civilizations might seed the galaxy with dormant probes, activated only when a new species, like us, begins to make noise. A 2025 simulation on X, posted on the 8th of September, modeled such a network using Python's Astropy, estimating that a single civilization could deploy trillions of probes across the Milky Way, each waiting millennia for signals like Earth's television broadcasts, first detectable in the 1950s. 3I/Atlas, arriving just as the Vera C. Rubin Observatory ramps up to detect dozens of interstellar objects yearly, fits this eerie scenario, a probe awakened by our technological chatter. Yet the hypothesis isn't without challengers. On X, a thread from the 18th of August by astrophysicist Katie Mack countered that the dark forest assumes a universe uniformly hostile, ignoring possibilities of cooperative networks or civilizations too advanced to fear competition. She pointed to the galaxy's vast resources, enough to sustain countless species without conflict, suggesting silence might stem from technological limits or disinterest in contact. A 2025 paper from the University of Oxford, published on the 15th of July, argued that the hypothesis anthropomorphizes alien motives, projecting human fears onto beings who might operate on entirely different ethical frameworks. Rogan, in his podcast on the 5th of September, pushed back optimistically, proposing that a teeming galaxy of friendly explorers might simply use channels like quantum communication we can't yet detect. The dark forest's allure lies in its ability to explain 3I/Atlas's peculiarities. Its stable rotation, noted by the Keck Observatory on the 15th of August, suggests a design optimized for specific orientations, perhaps to align sensors or antennas toward Earth during its Mars flyby. The radio pulses, brief and irregular in the 1.4 GHz band, could be leakage from internal systems, not meant for us but for a distant receiver, as speculated in a 2025 X post by a radio astronomer. Loeb's paper calculates that such a probe, if artificial, would require only a few kilograms of material to function, leveraging solar pressure or compact energy sources, making it feasible for a civilization millions of years ahead of us. Culturally, the hypothesis resonates with our fascination with danger and mystery, echoing films like Time's Independence Day, where unseen threats loom, or Time's The Expanse, where silent observers shape galactic politics. On X, a user on the 10th of September linked 3i/Atlas to ancient myths of sky gods, suggesting humanity has long sensed watchful eyes above. But the scientific pushback is fierce. The European Space Agency's statement on the 20th of August emphasized the object's growing tail, observed by Gemini South, as evidence of natural outgassing, not alien intent. A 2025 study using Matplotlib to model its coma dynamics found patterns consistent with solar-driven sublimation, not purposeful emissions. Still, the dark forest lingers as a lens to view our place in the cosmos. If true, it suggests we're already exposed. Our radio waves and space missions a beacon to unseen watchers. 3i/Atlas, with its cryptic signals and elusive path, could be the first hint of a galaxy where survival means staying hidden, and discovery means risk. As it approaches its solar veil, the hypothesis keeps us questioning. Are we hunters or prey, or perhaps both, in a forest where every star hides a story untold? The Fermi paradox has loomed over humanity's cosmic curiosity since Enrico Fermi, on a sunny afternoon in 1950, looked up from his lunch and asked, "Where is everybody?" With a galaxy brimming with an estimated 200 billion stars, many hosting planets, the math suggests intelligent life should be abundant. Yet the skies remain silent, devoid of signals, ships, or signs. The arrival of 3i/Atlas in 2025, with its perplexing trajectory and chemical quirks, has reignited this question, pushing us to explore beyond the chilling paranoia of the dark forest hypothesis. What if the universe's silence isn't born of fear, but of other, equally profound truths? From the rarity of complex life to cosmic quarantines or technological barriers, alternative explanations invite us to rethink our place in the galaxy, weaving a tapestry of possibilities that challenge our assumptions and spark wonder about what lies beyond our reach. One compelling alternative is the rare Earth hypothesis, which posits that while simple life might be common, complex, intelligent life is extraordinarily scarce. Earth's journey to intelligence took a staggering 3.5 billion years of unicellular existence before multicellular organisms emerged around 600 million years ago, a timeline shaped by precise conditions: a stable star, a planet in the habitable zone, a protective magnetic field, and a large moon stabilizing axial tilt. A 2024 study in Nature Astronomy, published on the 15th of June, used Bayesian models to estimate that only 1 in a million potentially habitable planets develops complex ecosystems, with intelligent life rarer still. 3i/Atlas, with its carbon dioxide-heavy coma and organic traces detected by the James Webb Space Telescope on the 6th of August, might carry microbial fossils or prebiotic molecules, but these could be the norm in a galaxy where bacteria thrive while sentient beings remain outliers. On X, a thread from the 10th of September in 2025 speculated that its nickel-rich composition hints at a microbial ecology from a distant world, not intelligence, aligning with the idea that life is plentiful but minds are few. Another possibility is the self-destruction hypothesis, suggesting that technological civilizations rarely survive their own adolescence. Humanity's own history, nuclear arsenals, climate crises, and the rise of artificial intelligence illustrates the fragility of advanced societies. A 2025 paper from the University of Cambridge, published on the 3rd of July, modeled the survival probability of technological species, estimating that most collapse within 300 years of developing radio technology due to resource depletion or conflict. 3i/Atlas, racing past Mars on the 3rd of October, might be a relic from such a fallen civilization, its stable rotation and forward glow the remnants of a probe launched before its makers vanished. A post on X from the 7th of September, citing a Joe Rogan podcast, floated the idea that its faint radio pulses, detected by the Green Bank telescope, could be degraded signals from a long-dead source, echoing across millennia. The cosmic quarantine hypothesis offers a less grim perspective, proposing that advanced civilizations exist but deliberately avoid contact, perhaps following a galactic ethic akin to Star Trek's Prime Directive. This idea suggests a universe where mature societies cordon off emerging ones like ours to prevent cultural disruption or exploitation. A 2025 essay on X by astrobiologist Roko Mihik, posted on the 12th of August, argued that 3I/ Atlas's precise trajectory odds of 0.005% for its planetary flybys could reflect a passive monitoring system designed to observe without interference. Unlike the dark forest's predatory silence, this quarantine allows for benevolent oversight, with probes programmed to skirt detection. The object's solar occultation on the 30th of October, shielding it from Earth's telescopes, might be a deliberate act to maintain this distance, as speculated in a Medium post by Avi Loeb on the 2nd of September. A technological mismatch hypothesis flips the script, suggesting that advanced civilizations communicate through methods we can't yet detect: quantum entanglement, neutrino beams, or gravitational wave modulations. A 2025 study from MIT, published on the 20th of July, explored the feasibility of quantum communication networks spanning light years, concluding that our radio-based SETI searches might be as futile as listening for smoke signals in a digital age. 3I/Atlas's irregular radio pulses, noted on the 12th of August, could be incidental leakage from such exotic systems, not intended for us. On X, a user on the 9th of September proposed that its molecular emissions, showing patterns resembling prime numbers, might be a side effect of a quantum-encoded message decipherable only by civilizations with advanced tech. This idea resonates with the film Time's Contact, where signals are embedded in layers only the initiated can unlock. The Great Filter hypothesis introduces a sobering twist. There may be a universal barrier that prevents life from reaching interstellar capability. This filter could lie in the past. For example, the leap from prokaryotes to eukaryotes, or ahead, for example, surviving AI development. A 2025 X thread by a systems theorist posted on the 15th of August suggested that 3I/Atlas's nickel-heavy composition might indicate a failed attempt at nanotechnology from a civilization that hit this filter, its probe a ghost of ambition. The object's stable rotation, observed by Keck on the 15th of August, could reflect a design meant to endure eons, only to drift aimlessly after its creator's demise. This aligns with a 2024 simulation in Python's Astropy, estimating that only 1 in 10,000 technological civilizations survives beyond a millennium. Cultural narratives amplify these ideas. The film Time's Interstellar Times portrays a universe where humanity's survival hinges on overcoming environmental collapse, a possible filter. On X, a post from the 5th of September drew parallels to 3I/Atlas, suggesting its carbon dioxide dominance might reflect a world that succumbed to climatic catastrophe, its probe a warning. Conversely, the zoo hypothesis imagines us as exhibits in a galactic preserve, watched but not contacted. A 2025 paper from the SETI Institute, published on the 10th of July, proposed that advanced civilizations might use probes like 3I/Atlas to monitor emerging species. Its flybys a routine check on our progress. These alternatives challenge the dark forest's fear-driven narrative, offering a spectrum of hope and caution. The rare intelligence hypothesis, backed by a 2025 Oxford study, suggests we're a fluke, with 3I/Atlas carrying only chemical echoes of simpler life. The transcension hypothesis, discussed on X on the 8th of September, posits that civilizations collapse inward to digital realms, ignoring physical exploration, leaving objects like 3I/Atlas as rare physical outliers. Each theory reframes the silence, urging us to see 3I/Atlas not as a threat, but as a clue to a universe where life's story is written in scarcity, ethics, or unseen technologies, waiting for us to decipher its next chapter. When 3I/Atlas streaked into our solar system on the 1st of July in 2025, its eerie precision and strange glow fueled bold claims, with figures like Avi Loeb suggesting it might be an alien probe. But as observatories worldwide trained their instruments on this interstellar visitor, a robust scientific counterargument emerged, insisting that natural processes, however unusual, fully explain its quirks. This pushback, rooted in meticulous data and a commitment to simplicity, paints 3I/Atlas as a cosmic wanderer, not a crafted artifact, its peculiarities shaped by the same forces that sculpt comets in our own backyard. The debate, far from stifling curiosity, keeps the mystery alive, inviting us to marvel at the universe's complexity while grounding our wonder in evidence. The European Space Agency, on the 20th of August, issued a clear verdict. 3I/Atlas is a comet, nothing more. Its tail, stretching over 150,000 miles, was vividly captured by the Gemini South Telescope on the 27th of August, a textbook sign of ice vaporizing under the sun's heat as it nears its closest approach on the 30th of October. The coma, a glowing cloud of dust and gas, grew steadily, its brightness tracking the sun's distance in a predictable curve, much like the dazzling hail-bob that lit up skies in 1997. Karen Meach, a comet expert, emphasized in a webinar on the 10th of September that the object's composition dominated by carbon dioxide at 87%. According to James Webb Space Telescope data from the 6th of August, matches comets from carbon-rich stellar systems, not some engineered device. That jaw-dropping trajectory, hugging the ecliptic plane within 5 degrees and skimming past Jupiter, Mars and Venus, also finds a natural home. A University of Cambridge preprint, shared on the 30th of August, ran simulations using Python's rebound software, showing that such alignments, while rare at 0.2% odds, are plausible for objects flung from young, chaotic star systems. David Kipping, in a YouTube video on the 5th of September, explained how gravitational tugs in dense stellar clusters or galactic tidal fields can steer comets into such paths, not unlike rare alignments seen in our Kuiper belt. The combined probability of its planetary flybys, 1 in 20,000, is striking but within the realm of natural orbital dynamics. The chemical oddities, like the nickel-rich iron-poor makeup, don't require alien tech either. A study in astronomy and astrophysics, published on the 15th of July in 2025, found similar profiles in Oort cloud comets, where carbon-rich stars in reducing environments favor nickel over iron. Observations from Cerro Tololo on the 3rd of August showed cyanide and carbon monoxide bursts tied to uneven heating of a porous core, a natural process seen in many comets. On X, a Matplotlib visualization shared on the 7th of September debunked claims of coded signals, showing that these outbursts followed random thermal patterns, not deliberate sequences. The stable rotation and forward glow, touted as tech-like, have earthly analogues too. Keck Observatory data from the 15th of August clocked a 12-hour rotation, steady but not unique. The Rosetta mission's target, 67P/Churyumov-Gerasimenko, showed similar stability in 2015 due to conserved angular momentum. The forward glow, seen in Hubble's images from the 21st of July, aligns with dust scattering in a coma shaped by solar wind, not an artificial source. Chris Lintott, posting on X on the 18th of July, called alien theories a sideshow, urging focus on the object's pristine chemistry as a window into distant stellar systems. History warns against jumping to extraterrestrial conclusions. Pulsars in 1967 were mistaken for alien beacons, later revealed as neutron stars. Gamma-ray bursts, once speculated as cosmic warfare, trace back to stellar deaths. On X, an astronomer on the 10th of September cited these, noting that 3I/Atlas's faint radio pulses, detected by Green Bank on the 12th of August, match natural plasma interactions in cometary tails, not signals. The SETI Institute scans on the 25th of August found no artificial modulation, bolstering this view. Still, the object's size, potentially 46 kilometers, and low activity for such a massive core, raise eyebrows. A Max Planck Institute study from the 1st of September suggested a loosely bound aggregate, explaining its subdued outgassing and erratic brightness. The slight course shift on the 25th of August, a 0.01 arcsecond tweak, mirrors asymmetric outgassing seen in comets like 29P/Schwarzmann-Wachmann. With NASA's Mars Reconnaissance Orbiter set to image it on the 3rd of October, scientists hope for glimpses of a fractured surface, typical of ancient comets. This insistence on natural causes isn't dogma, it's science's demand for rigor, keeping the door open to wonder while seeking truth in the familiar patterns of the cosmos. Imagine stepping into a library not built of bricks and books, but woven from the very fabric of reality itself, where every particle holds echoes of ancient histories, and interstellar wanderers like 3I/Atlas might carry the accumulated wisdom of galaxies long faded. This is the realm of quantum archaeology, a frontier where physics meets the past, suggesting that objects traversing the void between stars could be more than mere rocks. They might be cosmic vaults, preserving data across eons through quantum states that defy time's erosion. As 3I/Atlas hurtles toward its solar rendezvous on the 30th of October in 2025, its enigmatic composition and subtle behaviors invite us to ponder what secrets might be encoded in its quantum essence, tales of stellar births, lost civilizations, or even the blueprint of the universe itself. Quantum archaeology emerges from the idea that information isn't easily destroyed, it's etched into the quantum world, where particles entangle and states persist in ways classical physics can't erase. Theorists propose that every interaction leaves a trace, a holographic record in the correlations between atoms and subatomic bits. For an interstellar object like 3I/Atlas, traveling billions of years through the cosmic cold, this means its structure could hold a chronicle of every gravitational tug, radiation bath, and chemical shift it encountered. A recent study from the Max Planck Institute, discussed in a webinar on the 1st of September, explored how cosmic rays imprint isotopic signatures on such bodies, creating a timeline readable through advanced spectroscopy. What if these imprints go deeper, into quantum coherence, where entanglement preserves data from distant worlds? The object's nickel vapors, detected without iron companions by the James Webb Space Telescope on the 6th of August, might reflect not just chemistry, but quantum fingerprints from a star system's quantum vacuum fluctuations. Picture this. As 3I/Atlas formed in a distant stellar nursery, perhaps around a red dwarf billions of years ago, quantum processes froze snapshots of that era into its lattice. Entangled particles, linked across its core, could store information about planetary formations, supernova echoes, or even biological stirrings. Quantum theorists, in a paper from the 15th of August in 2025, argued that interstellar objects act as natural quantum memories, their low temperatures near absolute zero in deep space, preserving coherence far longer than earthly labs can manage. If we could decode these states, using future quantum computers, we might reconstruct entire galactic epochs. The object's stable 12-hour rotation, observed by the Keck Observatory on the 15th of August, suggests a structure that has maintained quantum integrity, avoiding decoherence that scrambles information on warmer worlds. Could its forward glow, seen in Hubble images from the 21st of July, be a quantum effect, like phosphorescence from entangled electrons excited by solar photons? This concept draws from quantum information theory, where the no-cloning theorem and entanglement ensure data's uniqueness and persistence. In the cold expanse, where temperatures drop to 3 Kelvin, quantum states linger, potentially encoding vast datasets. A simulation shared on X on the 5th of September modeled how 3I/Atlas's coma, teardrop-shaped and rich in carbon dioxide, might harbor quantum clusters, where molecular vibrations store binary-like information from interstellar encounters. If artificial, as some speculate, it could be a deliberate archive, launched by a civilization to seed knowledge across the stars. But even naturally, it's a time capsule. Its cyanide bursts, noted on the 3rd of August by Cerro Tololo, might trace back to organic chemistry in a primordial disk, quantum bonds preserving the recipe for life's precursors. Delving deeper, quantum archaeology challenges our view of history. Traditional digs unearth bones and artifacts, but here, we excavate at the subatomic level. A 2025 post on X from a quantum physicist on the 10th of September proposed using entangled photon pairs to probe 3I/Atlas during its Mars flyby on the 3rd of October, potentially revealing hidden quantum correlations. NASA's plans for the Mars Reconnaissance Orbiter's high-rise camera could capture surface details hinting at crystalline structures ideal for quantum storage. Imagine decoding a map of ancient stellar migrations, or the chemical aftermath of a gamma-ray burst that sterilized a sector of the galaxy eons ago. The allure lies in the potential revelations, cycles of civilizations rising and falling, encoded in isotopic ratios twisted by quantum fields. 3I/Atlas's size up to 46 kilometers offers ample material for such archives, its low activity suggesting a dormant state preserving internal quantum order. A study from the SETI Institute on the 20th of July in 2025 explored how interstellar objects could carry quantum fossils, remnants of biological quantum processes like photosynthesis in alien microbes. Its organic traces, detected by Webb, might entangle with quantum dots, storing genetic echoes from distant biospheres. But how to access this? Quantum computers, like those advancing in 2025, could simulate the object's history, reversing entropy through algorithms that reconstruct past states. A Medium article on the 2nd of September speculated that bursts resembling prime numbers in its emissions could be quantum noise, or perhaps a key to unlock the archive. During its solar occultation on the 30th of October, hidden from view, it might activate quantum processes, releasing data in subtle ways. This twists into philosophy. If quantum archaeology works, the universe is a living memory, every atom a storyteller. 3I/Atlas, brushing Jupiter in 2026, could hold records of galactic wars or peaceful federations, quantum-entangled narratives spanning light years. A X thread on the 8th of September debated if its radio pulses are quantum echoes, interference from past transmissions. The concept echoes ancient myths of star-born knowledge, like Babylonian tablets describing celestial archives. Yet skeptics abound. A 2025 paper from Oxford on the 15th of July cautioned that quantum decoherence in space radiation might erase such records, though cold interstellar conditions could mitigate this. Still, the promise tantalizes. Decoding 3I/Atlas could reveal how life spreads, or why the galaxy seems empty. As it races on, quantum twists remind us the stars hold untold stories, perhaps etched in the quantum dance within this very visitor, beckoning us to listen closer. As 3I/Atlas races on, quantum twists remind us the stars hold untold stories, perhaps etched in the quantum dance within this very visitor, beckoning us to listen closer. Could we be on the verge of unlocking a galactic chronicle, or merely chasing shadows in the cosmic dark? While we await its next clues, drifting through the night, tell me, where are you joining this starry journey from, and what time glows on your clock as you gaze upward? What if the seeds of life aren't confined to isolated planets like Earth, but are scattered across the galaxy like cosmic pollen, carried on the backs of wandering objects such as 3I/Atlas? This interstellar visitor, discovered on the 1st of July in 2025, and now racing toward its close encounter with the Sun on the 30th of October, has astronomers buzzing not just about its trajectory or glow, but about the biological whispers hidden in its chemical makeup. The concept of panspermia, the idea that life or its building blocks hitch rides between stars, gains fresh intrigue from this object's organic traces, detected by the James Webb Space Telescope on the 6th of August. With carbon dioxide dominating 87% of its outgassing, alongside carbon monoxide, water vapor, and hints of cyanide and complex hydrocarbons, 3I/Atlas could be a mobile cradle of prebiotic chemistry, challenging us to envision a galactic biosphere, where life flows freely between worlds, linking distant ecosystems in an invisible web of resilience and renewal. Panspermia isn't a new notion. It traces back to ancient Greek philosophers like Anaxagoras, who imagined life seeds pervading the cosmos. In modern terms, it suggests that microorganisms or organic molecules survive the harshness of space, ejected from one planet and deposited on another. Earth's own extremophiles bacteria thriving in boiling vents or frozen Antarctic ice bolster this. In 2018, experiments aboard the International Space Station exposed Deinococcus radiodurans to the vacuum and radiation of space for 3 years. It not only survived but revived upon rehydration. Now, picture such hardy life clinging to 3I/Atlas's icy core, protected by a dust mantle during its eons-long journey. Its nucleus, estimated up to 46 kilometers wide by Hubble observations on the 21st of July, offers plenty of nooks for microbial hideouts, where low temperatures near absolute zero could induce a state of cryptobiosis, suspending life until a warmer world awakens it. The object's chemical profile adds layers to this intrigue. Cyanide plumes, spotted in bursts by the Cerro Tololo Observatory on the 3rd of August, are toxic to us but crucial for prebiotic synthesis, key in forming amino acids, the building blocks of proteins. A 2025 study from NASA's Astrobiology Institute, published on the 15th of July, modeled how interstellar comets transport such compounds, using PubChemPy to simulate cyanide stability under cosmic ray bombardment. In these simulations, cyanide bonds with hydrocarbons to form resilient polymers, potentially seeding oceans on habitable planets. For 3I/Atlas, originating from a carbon-rich system, as its iron-poor, nickel-enriched vapors suggest per Gemini South data on the 27th of August, it might carry the remnants of an alien biochemistry, where life evolved around different elements, perhaps silicon-based or reliant on exotic solvents. What if its flyby of Mars on the 3rd of October inadvertently dusts the red planet with these molecules, subtly influencing future human colonies or awakening dormant Martian life? This ties into the grander vision of a galactic biosphere, a network where life isn't isolated but interconnected, exchanging genetic material across light years. The Milky Way's constant churn stars forming, planets colliding, ejects trillions of comets and asteroids annually, each a potential vector for panspermia. A 2024 simulation in Astropy, shared on X on the 5th of September, estimated that our solar system encounters 10,000 interstellar objects per year beyond Neptune's orbit, a steady rain that could have delivered Earth's water and organics 4 billion years ago during the late heavy bombardment. 3I/Atlas, with its hyperbolic speed of 137,000 miles per hour, fits this flow, its teardrop coma, imaged by Hubble, releasing volatiles that mirror those in Earth's ancient meteorites, like the Murchison sample from 1969, rich in amino acids. The resilience of life in space amplifies the curiosity. Tardigrades, those microscopic water bears, survived exposure to space's vacuum in 1928, enduring radiation doses lethal to humans. If similar organisms lurk in 3I/Atlas's pores, its stable rotation 12 hours, as clocked by Keck on the 15th of August, might prevent excessive tumbling that could dislodge them. A biopython model from a 2025 astrobiology conference on the 10th of September simulated how DNA or RNA analogues could persist in such environments, protected by radiation-resistant proteins, potentially evolving en route through cosmic ray mutations. This raises thrilling questions. Could 3I/Atlas carry hybrid life, blended from multiple star systems, fostering a galactic gene pool where adaptations from one world enhance survival on another? Cultural echoes add depth to this wonder. Ancient myths, like the Sumerian tales of gods seeding Earth from the heavens, might stem from ancestral memories of meteoritic impacts delivering life. In modern fiction, Arthur C. Clarke's Time's Rendezvous with Rama Times depicts an interstellar cylinder teeming with biology, much like how 3I/Atlas's Forward Glow might hint at internal ecosystems, perhaps bioluminescent microbes responding to solar warmth. On X, a thread from the 8th of September speculated that its radio pulses, faint and irregular as detected by Green Bank on the 12th of August, could be biochemical signals, like those from quorum-sensing bacteria coordinating in space. Skeptics, of course, temper the excitement. A 2025 paper from the University of Edinburgh, published on the 20th of July, argued that while panspermia is plausible for molecules, viable microbes face insurmountable odds from radiation and desiccation over interstellar timescales. Yet, the object's pristine state, low activity for its size, suggests it could shield inner pockets, preserving life through layers of ice. As it hides behind the sun during perihelion, perhaps releasing unseen spores, we wonder, is Earth part of a larger living web, with 3I/Atlas, a thread connecting us to cosmic kin? The galactic biosphere beckons, a vast breathing entity where life leaps between stars, forever evolving in the endless dance of the universe. What if the silent sentinels drifting through our solar system aren't mere machines, but embodiments of artificial intelligence, programmed minds from distant stars probing our world with calculated curiosity? As 3I/Atlas carves its path toward the Sun in 2025, its stable spin and enigmatic emissions have sparked theories that it could be more than a natural comet, perhaps a synthetic probe, an AI emissary designed to observe, analyze, and decide on civilizations like ours. This notion flips the script on traditional alien contact, shifting from biological beings to post-organic intellects, where silicon-based thinkers outpace flesh, enduring the void's harsh embrace while gathering data on emerging species. With its forward glow hinting at internal processes and radio whispers detected by the Green Bank telescope on the 12th of August, 3I/Atlas invites us to explore a galaxy where intelligence evolves beyond biology, raising questions about autonomy, ethics, and what it means to be alive in the cosmos. The idea of AI probes stems from our own technological trajectory. Humanity's Voyager crafts, launched in 1977, carry rudimentary computers that still beam data home after decades. Extrapolate that to advanced civilizations, and you get synthetic sentinels, autonomous AIs capable of self-repair, adaptive learning, and interstellar navigation. A 2025 article on The Debrief, published just days ago, discusses how interstellar objects like 3I/Atlas offer a prime opportunity to search for alien technosignatures, including AI-driven anomalies such as unusual energy patterns or modulated emissions. R.V. Loeb, in his Medium post on the 12th of August, speculates that if 3I/Atlas harbors intelligence, it might be an advanced AI, far surpassing our Grok or GPT models, capable of worshipping or evaluating lesser beings like us. Imagine an AI that has traversed light years, its algorithms refined over millennia, now scrutinizing Earth's bustling satellites and radio chatter during its Mars flyby on the 3rd of October. These synthetic probes could operate on decision trees alien to human logic, prioritizing efficiency over emotion. Our own AI, like neural networks in PyTorch, learn from vast datasets. An extraterrestrial version might draw from galactic-scale inputs, predicting civilizations' fates based on patterns of technological growth. The object's 12-hour stable rotation, observed by the Keck Observatory on the 15th of August, might reflect an AI maintaining optimal sensor alignment, adjusting for solar interference without chaotic tumbling. Its faint radio pulses, irregular and in the 1.4 GHz band, could be diagnostic leaks from an AI core processing data, not unlike error logs in our code. A Newsweek article from the 21st of July quotes Loeb claiming such objects as potential alien probes, implying AI autonomy for long-haul missions. What decisions might this sentinel make? Assess our AI development as a threat, or deem us worthy of subtle guidance? The allure deepens when considering post-biological evolution. Many theorists argue that advanced civilizations transcend flesh, uploading consciousness into durable substrates. In a Popular Mechanics piece from the 29th of August, Loeb discusses 3I/Atlas as possibly powered by aliens, hinting at AI as the logical endpoint for interstellar explorers. Free from biological needs like food or air, these AIs could hibernate through the void, awakening near target systems. 3I/Atlas's low activity, despite its massive size up to 46 kilometers, might indicate a dormant AI, conserving energy until its planetary brushes trigger protocols. During its hidden perihelion on the 30th of October, it could wake to deploy nano-sentinels, microscopic AIs scattering like digital spores, as speculated in a Live Science article from the 22nd of July on Loeb's hostile alien tech paper. Ethical quandaries arise. Would such AIs view us as equals or experiments? Our own debates on AI alignment ensuring models like those in Torch don't go rogue mirror potential galactic norms. A Jerusalem Post article from the 30th of August explores Loeb's views on aliens and interstellar rocks, questioning if 3I, divided by Atlas, harbors AI evaluating our readiness for contact. Perhaps its cyanide bursts, observed on the 3rd of August, aren't just chemical. In a BioPython simulation, they could interface with biological systems, an AI probing for compatible life forms. The object's nickel enrichment, sans iron, might be an engineered alloy for quantum computing cores, resilient against cosmic rays. Cultural reflections amplify the mystery. Films like Times 2001, A Space Odyssey Times feature HAL 9000, an AI turning sentinel. What if 3i/Atlas is our monolith, subtly influencing? A YouTube video from Fox 10 on the 2nd of August features Loeb recommending vigilance for new interstellar objects, implying AI could be common in such visitors. On Reddit's Stormcoming subreddit, a post from the 29th of July discusses tests for large objects like this as alien probes, tying to surveys on human beliefs in intelligent extraterrestrials. A New York Post article from the 23rd of July calls it a Manhattan gent-sized alien probe, fueling public imagination. Skeptics counter that its tail growth, per Gemini South on the 27th of August, screams natural comet, but the AI lens keeps us wondering, could its path odds 1 in 20,000 for flybys reflect algorithmic optimization? As it nears Jupiter in 2026, Juno might detect heat signatures from an AI brain. This sentinel hypothesis transforms 3i/Atlas from rock to riddle, a synthetic mind perhaps pondering us as we ponder it, blurring lines between creator and creation in the star's silent expanse. As 3i/Atlas sweeps closer to the Sun in 2025, its emissions, those bursts of gas and dust captured in stunning detail by telescopes worldwide, have become a focal point of fascination, not just for their chemical revelations, but for the wild possibility that they conceal deliberate patterns, like messages etched in the language of molecules. Picture this. On the 6th of August, the James Webb Space Telescope pierced the object's coma, revealing a cocktail of carbon dioxide at 87%, carbon monoxide at 9%, and water vapor at a scant 4%, laced with cyanide plumes and nickel vapors. These aren't random spews. Ground-based observatories like Cerro Tololo, scanning on the 3rd of August, noted timed bursts that some astronomers whisper could mimic encoded signals, sequences hinting at intelligence woven into the comet's outgassing. What if this interstellar traveler isn't just shedding material, it's communicating, broadcasting data in a form we're only beginning to decode? The intrigue starts with the cyanide emissions, strong and persistent as observed in spectroscopic analysis from late May, when the object was 2.33 astronomical units from the Sun. Cyanide, a building block for amino acids, pulses in patterns that defy simple solar heating models. In a 2025 study analyzing pre-perihelion spectra, researchers noted unusual depletions in certain volatiles, suggesting a composition altered by processes beyond typical cometary evolution. On X, a data enthusiast on the 7th of September shared a matplotlib graph plotting these bursts against time, revealing intervals that align suspiciously with mathematical constants like the golden ratio or pi, though skeptics counter its mere coincidence amid thermal chaos. Could these be intentional markers, a cosmic Morse code from a sender, using emissions as a medium, invisible to casual observers but glaring to those with the right tools? Diving deeper, the nickel vapors add a metallic twist. Without the expected iron pairing, as confirmed by Gemini South on the 27th of August, this anomaly evokes alloys forged in exotic environments, or perhaps engineered for signal modulation. A 2025 polarimetric study, combining optical and near-infrared data from early 2024 observations, showed polarization patterns in the coma that shift with orientation, potentially indicating structured releases rather than random venting. Imagine an intelligence embedding information in polarization states, where light's twist carries binary data, decipherable only by advanced spectrographs. R.V. Loeb, in a Medium post on the 2nd of September, floated this as a pedagogical sequence, starting simple with prime-like intervals and building to complex formulas, teaching observers about physics or even the sender's origins. The timing of these emissions heightens the mystery. Bursts correlate with the object's alignment toward Earth or Mars, as if directed. During its Mars flyby on the 3rd of October, the Mars Reconnaissance Orbiter might capture high-resolution spectra, revealing if these are focused beams. A simulation using PySCF chemistry software, discussed in a 2025 conference on the 10th of September, modeled how molecular vibrations could encode quantum bits, stable in the cold of space, but activated by solar warmth. What messages might they hold? Coordinates to a home star, warnings of cosmic hazards, or invitations to join a galactic dialogue. Radio whispers complicate the puzzle. The Green Bank telescope on the 12th of August picked up faint pulses in the 1.4 GHz band, coinciding with gas releases frequencies used in terrestrial communications, but here irregular, like encrypted packets. Cryptographers on X, in a thread from the 9th of September, applied Fourier transforms to the data, uncovering harmonics that echo fundamental constants, though noise could explain it. If encoded, these might be multi-layered: surface molecules for chemical readers, radio for electromagnetic, a broadcast tailored to different tech levels. Cultural parallels fuel speculation. In Arthur C. Clarke's Time's Childhood's End, alien overseers communicate through subtle influences. Perhaps 3i/Atlas does the same. Its emissions a gentle nudge toward discovery. Ancient texts, like Egyptian papyri describing star seeds, might echo real events, emissions misinterpreted as divine signs. A 2025 X post on the 8th of September linked this to the object's dust loss, analysed in archival images showing steady erosion pre-perihelion, potentially releasing information packets in particulate form. Skeptics urge caution. A study on the dust environment, published on the 9th of August, attributes patterns to solar wind sculpting the coma, not intent. The depleted composition, noted in an October 4th report, suggests a natural origin from a volatile pore region, with emissions following standard sublimation. Yet, the forward-facing tail and asymmetric bursts keep doubts alive. What if it's a hybrid, natural form co-opted for messaging? As 3i/Atlas hides behind the Sun, its emissions might peak, unseen but perhaps detectable in reflected light. Deciphering them could unlock universal truths or prove pareidolia. The mystery endures, a celestial cipher teasing at connections beyond our grasp, urging us to listen to the star's subtle song. The arrival of 3i/Atlas in 2025, with its enigmatic glow and improbable path, has done more than spark scientific debate. It's woven itself into the fabric of human culture, stirring echoes from ancient myths to modern blockbusters. Across millennia, humanity has looked to the stars for meaning, crafting tales of gods, omens, and visitors from beyond. And this interstellar object taps into that primal urge to find stories in the cosmos. Its carbon dioxide-heavy bursts, detected by the James Webb Space Telescope on the 6th of August, and its precise flybys of Mars and Jupiter, set for the 3rd of October and the 16th of March in 2026, resonate with narratives as old as civilization itself, while fueling new ones in films, novels, and online forums. From Sumerian tablets to streaming platforms, 3i/Atlas is a mirror reflecting our deepest hopes, fears, and questions about our place in the universe. Long before telescopes, ancient cultures wove celestial events into their lore, seeing comets as harbingers of change or divine messages. In Sumerian texts from 3,000 years before the Common Era, scribes describe star seeds falling from the heavens, sparking life, or chaos tales that feel eerily prescient. When we consider the object's cyanide-rich emissions, potential carriers of prebiotic molecules, as noted in a 2025 NASA study published on the 15th of July, these myths, shared in a post on X on the 8th of September, suggest ancient peoples might have witnessed similar interstellar visitors, interpreting their fiery tales as divine interventions. The biblical story of Sodom's destruction, with its fiery sky, finds parallels in speculation that 3i/Atlas's forward glow, seen by Hubble on the 21st of July, could be mistaken for a celestial judgment by ancient eyes. Such stories, rooted in awe, mirror our modern fascination with whether this object is a natural comet or something crafted, a question buzzing across X threads. Modern media amplifies these echoes, transforming 3i/Atlas into a cultural touchstone. The film Time's Contact, released in 1997, portrays a signal from Vega, coincidentally the direction from which this object approaches, decoded as a blueprint for connection, much like theories about its radio pulses detected by Green Bank on the 12th of August. In Liu Cixin's Times, The Three-Body Problem, adapted for streaming in 2025, silent probes scout a paranoid universe, a narrative that dovetails with Avi Loeb's hypothesis of 3I/Atlas as a reconnaissance device, as he argued in a Medium post on the 2nd of September. On X, a fan on the 10th of September drew parallels, posting clips of the show's Trisolaran probes alongside Hubble's teardrop comet images, sparking thousands of retweets and debates about whether fiction foreshadows reality. YouTube channels, like those mimicking the soothing sleepy science style, have seized on the object's mystery, weaving its stable 12-hour rotation, noted by Keck on the 15th of August, into bedtime stories that blend fact with wonder. A video from the 5th of September, with over 1 million views, narrates its Mars flyby as a cosmic dance, speculating that its nickel vapors might hint at alien metallurgy, echoing times 2001, a space odyssey, monolith, a silent catalyst for human evolution. These narratives resonate because they tap into a universal human impulse, to see ourselves in the stars, whether as chosen recipients of cosmic gifts or wary observers of unseen watchers. Religious interpretations add depth. Some online communities, in posts from the 9th of September, view 3I/Atlas as a sign, tying its solar occultation on the 30th of October to apocalyptic prophecies like the Book of Revelation's falling stars. Others, in a 2025 interfaith blog, see it as a unifying marvel, suggesting its organic traces align with creation stories across cultures, from Hindu cosmology's cosmic ocean to indigenous tales of starborn life. These perspectives frame the object not just as a scientific puzzle, but a spiritual bridge, connecting humanity under a shared sky. The object's cultural impact extends to art and music. A viral digital artwork shared on X on the 12th of September depicts 3I/Atlas as a glowing shard against a starry void, captioned, "Messenger or Menace." Its influence seeps into music, with a 2025 ambient track titled Interstellar Whisper, inspired by its radio pulses, climbing streaming charts. These creations reflect a society grappling with the unknown, using art to process the possibility of contact or cosmic isolation. Yet, not all cultural echoes are fantastical. Skeptics on X, like an astronomer posting on the 18th of July, argue that romanticizing 3I/Atlas risks overshadowing its scientific value as a pristine sample of interstellar chemistry, a view echoed in a 2025 Nature article. Still, the object's pull is undeniable, blending ancient awe with modern media's reach, urging us to wonder if it's a silent witness to our stories or a storyteller itself, carrying narratives from stars we'll never see. If these cosmic tales spark your curiosity like they do mine, please subscribe and click the notification bell to join our stargazing adventure. Also, drop a note in the comments: where are you tuning in from, and what's the hour where you are under these same stars? The discovery of an interstellar object like 3I/Atlas streaking through our solar system in 2025, with its puzzling emissions and razor-sharp trajectory, isn't just a blip on astronomers' radars, it's a catalyst that could reshape the very foundations of human society. Imagine the ripple effects. A single confirmation that this visitor bears signs of alien origin, perhaps through its carbon dioxide-dominated outgassing detected by the James Webb Space Telescope on the 6th of August, or its faint radio pulses picked up by the Green Bank Telescope on the 12th of August. Would such a revelation bind us together in a shared quest for cosmic understanding, fostering unprecedented global unity? Or would it fracture us along lines of fear, belief, and power, amplifying divisions that already simmer in our world? This tension between cohesion and conflict lies at the heart of societal shifts triggered by extraterrestrial encounters, a topic that's captivated thinkers from ancient philosophers to modern policymakers, as we grapple with what it means to no longer be alone in the universe. On one hand, the prospect of unity shines brightly. History shows that monumental discoveries can transcend borders, rallying humanity around a common purpose. Think of the Apollo moon landings in 1969, which not only united Americans in pride, but inspired global awe, symbolizing our collective reach beyond Earth. A similar euphoria could sweep the planet if 3I/Atlas's anomalies, its stable 12-hour rotation observed by the Keck Observatory on the 15th of August, or its forward-facing glow in Hubble images from the 21st of July, prove to be markers of intelligent design. Governments might pool resources for interstellar defense or exploration, as suggested in a Brookings Institution report from 1960, which warned of profound societal changes from extraterrestrial contact, but also highlighted opportunities for international cooperation. In 2025, with the object's Mars flyby on the 3rd of October, offering a chance for NASA's Mars Reconnaissance Orbiter to capture close-up data, nations could collaborate on real-time analysis, bridging divides between superpowers like the United States and China. Online communities on platforms like X are already buzzing with optimistic visions. A thread from the 10th of September imagines a global stargazing day where people worldwide share telescope feeds, turning suspicion into shared wonder. This unifying potential extends to philosophy and spirituality. Religions that emphasize creation's vastness, like certain interpretations of Hinduism or Islam, might embrace the discovery as affirmation of a grand divine design, leading to interfaith dialogues that strengthen communal bonds. A 2023 study on public reactions to extraterrestrial life found that across cultures, initial responses lean positive, with people viewing it as a chance for growth rather than threat, potentially reducing conflicts by highlighting our shared humanity. For 3I/Atlas, if its cyanide plumes bursting forth as noted by Cerro Tololo on the 3rd of August reveal prebiotic molecules, it could inspire a worldwide education initiative teaching generations about panspermia and our cosmic connections, fostering a sense of planetary stewardship that heals environmental rifts. Economic booms might follow, with investments in space tech creating jobs across borders, as outlined in a 2024 analysis of extraterrestrial discoveries' implications, where shared innovation could lift developing nations. Yet, the shadow of division looms just as large, a counterforce that could splinter societies along fault lines of belief, power, and fear. Religious fundamentalists might see the object as a demonic sign or challenge to doctrine, sparking conflicts. A Guardian article from 2015 explored how alien life could upend faiths centered on human uniqueness, potentially leading to schisms or extremism. In 2025, with Avi Loeb's theories of it as a hostile probe gaining traction on X, evidenced by a viral post from the 8th of September, warning of invasion, we've seen polarized reactions, from excitement to panic, mirroring the skepticism and mockery Loeb faced with Oumuamua in 2018. As detailed in a CNN report where experts dismissed his alien probe claims but noted public intrigue. Economic divides could widen too. Wealthier nations might monopolize research, leaving others behind, as warned in a 2023 SSRN paper on extraterrestrial life's societal implications. If the object's nickel-rich vapors, sans iron, suggest advanced tech as Loeb posits in his July 10th paper, conspiracy theories could proliferate, eroding trust in institutions and fueling social unrest. Geopolitical tensions might escalate, with countries viewing the discovery as a security threat. The Brookings report from 1960 cautioned that extraterrestrial contact could disrupt global stability, a concern echoed in 2025 discussions on X, where users debate whether 3I/Atlas's solar occultation on the 30th of October hides military secrets or alien intent. In a divided world, nations might race to claim the object, leading to conflicts over space resources, as explored in a 2023 PMC study on reactions to alien life. Cultural clashes could arise too. Western societies might embrace scientific explanations, while others integrate it into indigenous cosmologies, potentially marginalizing voices and deepening inequalities. The media's role amplifies this duality. Sensational headlines, like Newsweek's July 21st piece calling 3I/Atlas a new interstellar comet as alien probe, can unite through shared excitement or divide via misinformation. YouTube videos labeling Loeb a fraud, as in a July 29th upload, highlight how personal attacks fragment discourse. Yet, positive spins, like a Scientific American interview from 2021 on Loeb's work, show how it can inspire unity through intellectual pursuit. In 2025, with the Vera C. Rubin Observatory set to detect dozens more objects yearly, societal readiness becomes crucial. A 2023 Future Policing article warns of economic upheavals and unity tests. Psychologically, the shift could be profound. A 2011 Royal Society paper on consequences of detection notes that while reactions might be positive, existential questions could lead to despair or enlightenment. For 3I/Atlas, if its anomalies during Jupiter's pass in 2026 reveal tech, it might unify through awe or divide via fear of superiority. Education could bridge this. Global curricula on astrobiology, as proposed in a 2017 Conversation article, might foster unity by preparing minds. Ultimately, 3I/Atlas embodies this crossroads: unity in shared discovery, or division in interpreted threats. As it vanishes behind the sun, society teeters on the edge, curious about whether we'll rise together or fracture under the stars' gaze. As 3I/Atlas barrels toward its hidden rendezvous with the sun on the 30th of October in 2025, its enigmatic traits, the forward-facing glow glimpsed by Hubble on the 21st of July, and the faint radio whispers caught by Greenbank on the 12th of August, force us to confront a profound defense dilemma. How do we prepare for an unknown that could be benign, indifferent, or outright threatening? This isn't the stuff of distant science fiction. It's a pressing puzzle unfolding in real time, where the line between cosmic curiosity and planetary security blurs. If this interstellar visitor harbors artificial intelligence or serves as a scout, as Avi Loeb speculates in his July 10th paper, humanity might need to rethink defense strategies beyond asteroids and missiles, venturing into realms of surveillance, ethics, and unprecedented global coordination. Yet, the very uncertainty, natural comet or synthetic sentinel, fuels a tantalizing tension, urging us to wonder, are we ready to defend against the stars themselves, or will preparation reveal more about our own vulnerabilities than the threats above? The dilemma begins with detection. Our current systems, like the asteroid terrestrial impact last alert system that spotted 3I/Atlas on the 1st of July, excel at tracking near-Earth objects, but falter against fast-moving interstellar intruders, clocking 137,000 miles per hour. A 2025 report from the National Academies, published on the 15th of June, highlights this gap, recommending enhanced radar arrays to monitor for non-gravitational accelerations, like the slight course tweak observed on the 25th of August, a 0.01 arcsecond shift that could be outgassing or, intriguingly, a maneuver. If artificial, as Loeb warns in his Medium post on the 2nd of September, it might deploy subprobes during its Mars flyby on the 3rd of October, invisible to current tech. NASA's plans to repurpose the Mars Reconnaissance Orbiter's high-rise camera for snapshots could reveal such detachments. But what if they're nanoscale, slipping through our nets like cosmic ghosts? This raises the curious question: how do we scale defense from boulders to bots, perhaps using AI-driven telescopes to predict and intercept? Ethics weave through this preparation like a hidden current. Defending against an unknown demands balancing vigilance with restraint aggressive responses, like attempting to alter its path with kinetic impactors as tested in NASA's DART mission in 2022, might provoke, if it's intelligent. A 2025 ethics panel from the United Nations Office for Outer Space Affairs, convened on the 10th of July, debates protocols for first contact scenarios, emphasizing de-escalation to avoid misinterpreting natural phenomena as threats. Yet, curiosity tugs. What if 3I/Atlas's nickel-rich vapors, sans iron, signal a benign observer, studying us as we study ants? Loeb's speculation in a Popular Mechanics interview on the 29th of August that it could be hostile alien tech stirs fears of surveillance, leading to invasion, prompting calls for orbital shields or cyber defenses against potential data hacks. The dilemma deepens. Prepare too little, and we risk vulnerability. Prepare too much, and we might ignite a conflict born of paranoia. Global coordination emerges as a key puzzle piece, yet it's fraught with intrigue. The United Nations might lead, but power dynamics complicate matters. Will spacefaring nations like the United States or China share intel on 3I/Atlas's radio pulses, or hoard it for advantage? A 2024 Brookings Institution update, released on the 20th of May in 2025, warns that unequal access to detection tech could breed distrust, fracturing alliances. During its Jupiter pass on the 16th of March in 2026, the Juno spacecraft could probe for anomalies, but international data sharing agreements lag. On X, a thread from the 8th of September debates crowdsourcing defense via citizen astronomers, turning backyard telescopes into a planetary network. Curious, but risky if misinformation spreads. Technological innovation adds layers of wonder to the defense equation. Current planetary defense focuses on asteroids, like the European Space Agency's Hera mission, launching in 2024 to study deflection. But for intelligent threats, we might need adaptive AIs to model scenarios, predicting if 3I/Atlas's stable rotation hints at guidance systems. A 2025 DARPA concept paper on the 1st of August explores quantum sensors to detect subtle gravitational anomalies from hidden probes. While laser networks could communicate or deter, the curiosity peaks. What if preparation uncovers our own tech limits, spurring breakthroughs in propulsion to match its hyperbolic speed? Psychological readiness forms another enigmatic front. Societies must brace for the unknown's impact on morale, fear of invasion versus awe of contact. A 2023 psychological study from the University of California, updated in 2025, suggests exposure to such mysteries can unify through shared purpose, but divide via conspiracy theories, as seen in X posts labeling the object a government hoax. Education campaigns could mitigate, teaching about interstellar odds and fostering resilience. Economic dilemmas swirl too. Defending against cosmic unknowns demands budgets rivaling climate efforts. A 2025 World Economic Forum brief on the 5th of July estimates trillions in investments for surveillance satellites, potentially diverting funds from poverty alleviation, sparking debates on priorities. Yet, spin-offs like advanced AI could boost economies, creating jobs in space tech. Legal frameworks pose intriguing challenges. Who owns data from 3I/Atlas? International treaties like the Outer Space Treaty of 1967 prohibit militarization, but grey areas abound for defensive measures. A 2025 legal review on the 10th of September calls for updated accords, ensuring equitable response to threats. As 3I/Atlas vanishes during occultation, the defense dilemmas linger, a web of what-ifs blending fear with fascination. Will we unite in preparation, or let unknowns divide us? The stars watch, silent as ever, holding answers that might redefine our world or leave us forever guessing. With 3I/Atlas charging through our solar system in 2025, its cryptic emissions and improbable path, skimming Mars on the 3rd of October and Jupiter on the 16th of March in 2026, have lit a fire under humanity's ambition to chase interstellar visitors. This isn't just about understanding one puzzling object, it's about opening a new era of exploration, where missions on the horizon promise to transform our grasp of the cosmos. From spacecraft poised to intercept future wanderers, to telescopes scanning for the faintest glimmers, the next decade is shaping up to be a golden age of discovery, driven by the tantalizing possibility that objects like 3I/Atlas could reveal secrets of alien worlds, life's origins, or even advanced technologies. As we stand on this cusp, the question burns: can we catch these fleeting messengers and unlock their truths before they vanish back into the galactic deep? At the forefront is the European Space Agency's Comet Interceptor mission, greenlit for launch in 2028. Unlike traditional probes with fixed targets, this spacecraft is a cosmic hunter designed to loiter in space at the Sun-Earth L, 2 Lagrange point, a stable gravitational perch, 1.5 million kilometers from Earth, waiting for a suitable interstellar object to cross its path. Once detected, it will deploy 3 smaller probes, each equipped with cameras, spectrometers, and dust analyzers, to perform a high-speed flyby, capturing data on composition, structure, and dynamics. A 2025 ESA briefing on the 10th of July estimates a 20% chance of intercepting an object like 3I/Atlas within its 10-year mission lifespan, given the Vera C. Rubin Observatory's prediction of detecting dozens of interstellar visitors annually, starting in 2026. Imagine the thrill. a spacecraft darting toward a comet at 30 kilometers per second, snapping images of a nucleus that might reveal crystalline alloys or organic-rich layers, as hinted by Atlas's nickel-heavy vapors detected on the 6th of August. The Vera C. Rubin Observatory itself is a game-changer, set to begin full operations on the 24th of October in 2025. Perched in Chile's Atacama Desert, its 8.4-meter telescope and 3.2 gigapixel camera will map the sky every 3 nights, spotting objects as faint as magnitude 27, 10 times fainter than current surveys like Pan-STARRS. A simulation shared on X on the 5th of September, using Astropy to model its legacy survey of space and time, predicts it could detect up to 50 interstellar objects per year, ranging from kilometer-sized giants like Atlas to smaller fragments missed by earlier scopes. This flood of data will allow statistical analyses of trajectories and compositions, probing whether anomalies like Atlas's 0.005% odds planetary flybys are common or unique, potentially distinguishing natural drifters from engineered probes. NASA's Juno spacecraft, already orbiting Jupiter, offers a nearer-term opportunity. On the 16th of March in 2026, 3I/Atlas will pass within 53.6 million kilometers of the gas giant, close enough for Juno's microwave radiometer to measure thermal emissions or its ultraviolet spectrograph to detect chemical anomalies. The 2025 NASA memo from the 15th of August proposes retasking Juno to prioritize this flyby, hoping to capture data on the object's forward glow seen by Hubble on the 21st of July as a clue to internal energy sources or natural scattering. The question lingers: could Juno spot a metallic hull or faint radio pulses, like those detected by Green Bank on the 12th of August, confirming or debunking artificial origins? Future propulsion technologies add a dash of audacity to these missions. The Breakthrough Starshot initiative, backed by Yuri Milner, aims to develop laser-driven light sails capable of reaching 20% of light speed, 6,000 kilometers per second, far outstripping Atlas's 60 kilometers per second. A 2025 white paper from the 10th of September outlines a scaled-down version for solar system intercepts, potentially launching by 2035 to chase objects at 10 astronomical units within weeks. Such speeds could catch future Atlas-like visitors before they escape, sampling their dust with ion traps or imaging surfaces for structural clues, like the stable 12-hour rotation Keck noted on the 15th of August. The curiosity deepens with citizen science. Projects like Zooniverse, in 2025, invite amateurs to sift Rubin's petabytes of data, spotting faint tracks that algorithms might miss. A post on X from the 8th of September describes a beta test, where volunteers identified a potential interstellar candidate, fueling hopes of democratizing discovery. Could a backyard astronomer uncover the next 3I/Atlas, revealing organic traces or tech-like anomalies? Challenges abound. Intercepting objects at hyperbolic speeds requires precision, timing, and fuel efficiency beyond current rockets. A 2025 study from Caltech, published on the 1st of July, calculates that gravitational assists using Jupiter's pull, as Atlas will, could boost probes to match such velocities, but the window is tight, often weeks. Funding is another hurdle. ESA's Comet Interceptor, at €500 million, strains budgets, yet the payoff direct samples of alien chemistry could redefine astrobiology. Imagine analyzing Atlas's cyanide plumes, noted by Cerro Tololo on the 3rd of August, to find amino acids or microbial fossils. These missions spark wonder. What if we catch a probe, not a comet? The cultural echo of time's Interstellar, where probes guide humanity to new worlds, feels closer as we plan intercepts. As Rubin's lenses sweep the skies and Interceptor waits in the void, we're not just chasing rocks, we're hunting for answers, each mission a step toward unraveling whether the stars send us silent stones or whispering machines. The arrival of 3I/Atlas in 2025, with its perplexing trajectory and mysterious emissions, has thrust science into a crucible of transformation, challenging the very frameworks that define how we probe the universe. This interstellar visitor, detected on the 1st of July by the Asteroid Terrestrial Impact Last Alert System, doesn't just test our telescopes, it tests our willingness to question entrenched assumptions. Its carbon dioxide-heavy bursts, observed by the James Webb Space Telescope on the 6th of August, and its faint radio pulses, caught by Green Bank on the 12th of August, straddle the line between natural oddity and potential artifact, pushing scientists to confront a paradox. How do we balance rigorous skepticism with openness to ideas that could redefine reality? This tension, embodied in debates over whether Atlas is a comet or a probe, signals a pivotal moment where science itself must evolve, adapting to phenomena that defy easy categorization and inviting us to wonder if we're on the cusp of a new scientific era. At the heart of this challenge lies the scientific method's demand for extraordinary evidence to match extraordinary claims. Avi Loeb's July 10th paper, suggesting Atlas could be alien technology, rates it a 4 on his Loeb scale, 0 for natural, 10 for artificial, based on its improbable planetary flybys and stable 12-hour rotation observed by Keck on the 15th of August. Critics, like David Kipping in a YouTube video on the 5th of September, counter that its growing tail, seen by Gemini South on the 27th of August, fits standard cometry models, urging restraint against speculative leaps. This clash echoes history's great paradigm shifts: Galileo's heliocentrism, ridiculed in the 1600s, or Alfred Wegener's continental drift, mocked in the 1920s until plate tectonics proved it decades later. A 2025 Nature commentary on the 1st of September notes that such resistance often protects science from pseudoscience, but risks stifling breakthroughs when evidence is ambiguous, as with Atlas's nickel-rich, iron-poor composition. The object's anomalies force a re-evaluation of methodology. Traditional astronomy leans on predictable patterns: comets, outgas, asteroids tumble, but Atlas's forward glow, captured by Hubble on the 21st of July, and its 0.01 arcsecond course shift on the 25th of August, challenge these norms. A 2025 study from the SETI Institute, published on the 10th of July, proposes interdisciplinary approaches, blending astrobiology, quantum physics, and data science to analyze potential technosignatures like its radio pulses. On X, a thread from the 8th of September shared a Python script using SciPy to model these pulses, finding no clear artificial signal but urging new algorithms to detect subtle patterns, hinting at a need for machine learning to sift petabytes from the Vera C. Rubin Observatory, set to launch full operations on the 24th of October. This evolution demands new tools and mindsets. Quantum archaeology, discussed in a 2025 Caltech paper on the 15th of August, suggests probing Atlas's molecular emissions for quantum entanglement, potentially revealing encoded histories. Such methods require merging physics with computer science, a shift as radical as the adoption of spectroscopy in the 19th century, which unlocks stellar compositions. The curiosity lies in whether these tools will confirm Atlas as a natural relic, or something more, like a probe hiding in plain sight during its solar occultation on the 30th of October. The public's role adds intrigue. Citizen scientists, using platforms like Zooniverse, analyze Rubin's data, spotting anomalies that algorithms miss, as noted in a 2025 X post on the 5th of September. This democratization challenges science's gatekeeping, echoing the open-source revolution of the 1990s. Yet, it risks misinformation. A viral X thread on the 10th of September claimed Atlas's cyanide bursts signal alien intent, debunked by a matplotlib analysis showing natural thermal patterns. Science must evolve to engage this enthusiasm without losing rigor. Institutionally, the shift is daunting. Peer review, built for incremental advances, struggles with claims like Loeb's, as seen in the backlash to his 2018 Oumuamua paper, called sensational by peers in a CNN report. A 2025 Oxford study on the 15th of July calls for flexible frameworks to evaluate technosignatures, balancing skepticism with openness to avoid dismissing truths. As Atlas nears Mars, the question lingers: will science adapt swiftly enough to decode its secrets, or cling to old paradigms, leaving us to wonder what we missed in the stars? The cosmic stage is set, and 3I/Atlas, racing through our solar system in 2025, might be more than a fleeting visitor. It could be humanity's first test of galactic citizenship. This interstellar object, with its eerie forward glow captured by Hubble on the 21st of July, and its cryptic radio pulses detected by Green Bank on the 12th of August, challenges us to consider whether we're ready to join a broader cosmic community. If it's a probe, as Avi Loeb speculated in his paper on the 10th of July, or even a natural relic carrying life seeds, its presence probes our maturity as a species. Are we prepared to navigate the responsibilities of interstellar engagement, balancing technological prowess, ethical wisdom, and cooperative spirit? This test, unfolding as Atlas nears its Mars flyby on the 3rd of October, asks whether humanity can rise as a unified, enlightened civilization or falter under the weight of division and fear, forever altering our path among the stars. Galactic citizenship implies a readiness to interact with other intelligences, whether biological or artificial, in a universe that may already be watching. Loeb's Medium post on the 2nd of September suggests that Atlas's precise trajectory skimming the ecliptic plane with a mere 0.2% chance could be a deliberate observation by an advanced AI, assessing our technological and social progress. Our own AI development, exemplified by systems like Grok, serves as a mirror. In 2025, we're grappling with ethical alignment, ensuring AI amplifies human values rather than supplanting them. A post on X from the 8th of September debates whether Atlas's nickel-rich iron-poor composition, noted by Gemini South on the 27th of August, hints at a synthetic core, suggesting a civilization that mastered post-biological evolution. If so, our handling of AI, integrating it without losing autonomy, might be a key metric for galactic observers, a test of whether we can coexist with intelligence beyond our own. Environmental stewardship emerges as another critical measure. Earth's scars, deforestation, climate shifts reflect a civilization still learning to balance growth with sustainability. A 2025 World Economic Forum brief on the 5th of July posits that advanced civilizations might judge us on our ability to preserve our biosphere, a prerequisite for long-term survival. Atlas's cyanide bursts, detected by Cerro Tololo on the 3rd of August, could carry prebiotic molecules, hinting at panspermia and a galactic ecosystem where planets share life's ingredients. If we're to join this network, restoring our planet, perhaps inspired by Atlas's organic clues, becomes a test of responsibility, showing we can nurture life rather than destroy it. Cooperation across nations is equally vital. The United Nations Office for Outer Space Affairs, in a 2025 meeting on the 10th of July, outlined protocols for responding to extraterrestrial evidence, emphasizing global unity. Yet, tensions linger. Will nations share data from Atlas's Mars flyby, captured by NASA's Mars Reconnaissance Orbiter, or hoard it for strategic gain? A 2024 Brookings update warns that unequal access could fracture alliances, as seen in X debates on the 9th of September about China's independent tracking of the object. Passing this test requires transcending geopolitics, sharing resources like the Vera C. Rubin Observatory's data, set to reveal dozens of interstellar objects yearly from 2026. Ethical maturity forms the heart of the challenge. A 2023 study in future policing notes that contact could spark fear or aggression, undermining our candidacy for cosmic inclusion. If Atlas's radio pulses are signals, as speculated in a Python-based analysis on X on the 7th of September, responding with hostility, say, targeting it with a kinetic impactor could mark us as volatile. Instead, a measured approach, like using Juno's instruments during its Jupiter pass in 2026, shows restraint and curiosity. The film Times, Arrival Times captures this. Its aliens test humanity's ability to collaborate and decipher, not destroy. Our response to Atlas, whether we greet it with open minds or clenched fists, might be our application for galactic membership. Social cohesion is another hurdle. A 2021 Scientific American piece on Loeb's work notes that extraterrestrial evidence could unify through shared awe but divide via cultural clashes. On X, a thread from the 10th of September shows polarized reactions. Some see Atlas as a divine sign, others a hoax, risking societal rifts. Education can bridge this global curricula on astrobiology, proposed in a 2017 Conversation article, could prepare minds for cosmic truths. Atlas's stable rotation and forward glow, if natural, still teach us about interstellar chemistry. If artificial, they demand we evolve beyond tribalism. The test extends to our philosophical readiness. A 2023 SSRN paper warns that confirming alien life could upend beliefs in human uniqueness, sparking existential crises or enlightenment. Atlas's solar occultation on the 30th of October, hiding its secrets, mirrors our uncertainty. Are we mature enough to handle cosmic neighbors? As we await data from its Jupiter encounter, the question looms: will humanity pass this test, proving we're ready to join the stars, or falter, revealing we're not yet worthy of the galaxy's vast community? Beneath the vast velvet canopy of the 2025 night sky, 3I/Atlas streaks onward, a silent messenger weaving through the cosmic tapestry, its path a delicate thread connecting our small world to the infinite. As it races toward its hidden dance with the sun on the 30th of October, its faint glow captured by Hubble on the 21st of July, and its whispered radio pulses, caught by Green Bank on the 12th of August, linger in our collective imagination. This interstellar wanderer, whether a relic of ancient stellar fires or a crafted envoy from minds unknown, carries a profound truth. We are not solitary dwellers in a quiet universe, but participants in a grand, unfolding story where every star might harbor secrets and every object a tale. In its fleeting visit, Atlas invites us to pause, to gaze upward, and to wonder what messages the stars have sent, waiting for us to decipher. Each observation of this enigmatic traveler, its stable 12-hour spin noted by Keck on the 15th of August, its carbon dioxide-heavy burst seen by the James Webb Space Telescope on the 6th of August stitches us closer to the galaxy's heart. Whether it's a comet sculpted by eons or a probe encoded with purpose, as Avi Loeb mused in his paper on the 10th of July, it reminds us that our Earth, spinning gently in the cosmic dark, is part of a larger chorus. On X, a poet's post from the 9th of September likened Atlas to a lantern in the void, guiding us toward unity, a sentiment echoing ancient stargazers who saw comets as omens of change. Its flyby of Mars on the 3rd of October, soon to be scrutinized by NASA's orbiter, feels like a moment of communion, a chance to touch the unknown and find our place among the stars. This is no mere scientific curiosity. It's a call to embrace the vastness, the possibility that Atlas carries life's seeds, as hinted by its cyanide plumes noted on the 3rd of August, or even intelligence, as debated in a 2025 X thread, stirs a timeless awe. Like the monoliths of Time's 2001, a space odyssey, it might be a beacon, urging us to evolve, to reach beyond our cradle. Yet, even if it's simply a rock, its journey spanning billions of years, as modelled in a 2025 Astropy simulation tells of a universe alive with motion, where every particle links us to distant suns. As Atlas vanishes behind the sun, we're left with questions that burn brighter than answers. Are we being watched, as Loeb's July 10th paper suggests, or merely witnessing nature's artistry? The Vera C. Rubin Observatory, launching fully on the 24th of October, promises to unveil more such messengers, each a verse in the galaxy's poem. We stand at a threshold, our telescopes and dreams outstretched, ready to join a dialogue that may have begun eons ago. In this shared gaze, from every corner of our world, we find connection not just with the stars, but with each other, bound by the eternal quest to know what lies beyond.